Welcome to the ultimate Solidity Smart Contract course for complete beginners, where the goal is to take you from zero to kickstarting your career as a Solidity developer in under 4 hours. We will start off with learning the fundamentals of Solidity, where you'll be doing a lot of exercises on variables, arrays, and functions. With that, we will build small smart contracts like a calculator, a crypto token, an expenses tracker, and even a game. I will also show you how you can deploy your smart contracts to the Sepolia test network so you can use them live. Then you'll move on to more advanced topics like mappings, structs, modifiers, and loops. You will learn how dApps like OpenZeppelin use Solidity Events to talk and get updates from the blockchain, and how two contracts can fully talk to each other through something called interfaces. With all this knowledge combined, you will build your own Twitter smart contract where a user can create a profile, create a tweet, and even like the tweet all through the blockchain. But that's not all. You will implement your own Twitter smart contract into a Twitter dApp using JavaScript, React.js, and Web3.js. So you can interact with your smart contract on a real live front-end app. Wow. Now, if you want to code along with it, which I highly recommend, and do all the exercises, hit the link down below in the description that will take you to a GitHub repository that has all the exercises and solutions in order for you to use. Other than that, let's get started. Now, if you want to binge watch this like Netflix and keep track of your progress, I have decided to package all of this up into an amazing free course. All you have to do is click the link down in the description, sign up, and you'll have access to a completely free course where you will see step-by-step videos. You can keep track of your progress, and it will be a much better experience for you. Other than that, let's get back to the video. Let's talk about what is Solidity and how do you use it, where do you use it. It is a programming language that creates smart contracts and instructs them how to behave. Now, basically what you do is you write code for smart contracts that are put on the blockchain. It's just like normal coding, but you're doing it for the blockchain side. And in terms of how do we actually run this, where when you write Solidity code, that gets compiled down to, as we all know, bits and bytes, ones and zeros, and that runs on something called an EVM, and that is an Ethereum virtual machine. Think of it as just simply servers that run your code, and that's it. So Naz, what can you build with it, you might be asking? Well, a lot of cool stuff. First thing you can build is called dApps, which are decentralized applications. Think of it as Facebook, but decentralized, meaning your application is not connected to just one simple server like Facebook. Instead, your application and your data is spread all throughout different nodes around the world, making it a ton more safe. Second thing is we got decentralized social media. That is so cool. For example, Orb is one of the companies that's doing it. They're building social media where you own your data. As you can see right here, decentralized social media platform. Pretty awesome, I would say so. And then we got DAOs, which are decentralized organizations. And think of it as an organization. Instead of having top-level people, CEOs, co-founders, you have people right here. For example, you have holders, which are holders of your NFT collection or of the token, whatever it might be. And then you got your proposal. And what happens is that you have people that create the proposals. Let's just say, hey, my proposal today is we want, as a organization, we want to buy this building. So they create a proposal that gets voted on by the holders, and then the holders decide, hey, is this proposal going to go through, which is a check mark, or no, meaning it's no good. And if it goes through, then great, that will be created into a contract, and the organization will go ahead and go with that proposal. It makes it a lot more decentralized instead of having a top level, the big brother, right? They're looking over you. No, this is the opposite of that. Of course, then we got NFTs, which if you don't know what NFTs are, they are digital assets on the blockchain. They can be used as PFPs, as access to certain applications. This is one of my favorite ones called the Azuki, and it's honestly one of the best ones, and I love it the way it looks. And of course, we can create crypto. You can build your own crypto coin, like for example, the Ethereum coin, like the Bitcoin, like the, as we all know, the Dogecoin, yeah, like Ape coin, which is built by the Bored Ape Yacht Club. And you can create your own coin to use in your own platform. That is the cool part, my friends. Imagine having the Nas coin, and then hey, if you use this Nas coin, you get these benefits, and so forth and so forth. So many potential opportunities there. Moving forward here, and of course, games. The biggest thing by far is games, my friends, okay? Instead of you having to buy gaming characters and basically not own them, when you buy characters, they are on the blockchain side, and you can sell those characters whenever you want. You can level those characters up and make them higher level and then sell them for a higher price. You can find certain things in the game that can actually be sold in the game as well. So it's not only is a way of monetizing what you're actually doing in the game, but it also gives you the ability to own your own shit, is how I like to say it. And why? Like I said, you own the data. You own the data. You are the owner and nobody else. That's right. It is all mine. That's exactly it. And so that's the point of Solidity. Of course, at the same time, blockchain developers on average make $110,000 to $250,000 a year as well. And if you look up Solidity developers on LinkedIn, they make a pretty good amount of money, $120K to $200,000 a year. Of course, depending on what time you're looking at this. This is my current time in my situation. So let's talk about Web 2 versus Web 3 because this goes very much deep into that, and Solidity is very heavy in that. Before with Web 2, what do we used to do? You had a user, which is you, the person. You would use an application, let's just say Facebook. And of course, that application saves all your data on the server and on the database somewhere in the cloud. With Web 3, however, it's a little bit different. You have a user that signs in with a crypto wallet. With the crypto wallet, it's your own wallet where you have your own private keys. You use that to sign in with your DAPP, and then that DAPP talks to the blockchain. And so all your data is saved on the blockchain on these different servers all around the world, and you are the one in control of that data. Let's go ahead and create your first Solidity Smart Contract. In order to run Solidity, we're going to use something called remix.ide right here. So go into Google, just type in remix.ide, and you should see your first solution right here, remix.ethereum.org. That's the one you want to use. Click on that one. Next thing, we're going to create a new workspace just by hitting plus right here. And let's go and rename this workspace to be something like Solidity Learning. I don't know. Whatever it is you want to call it. As you can see, I'm not the best at spelling, so whatever. And you have 3 folders now: contracts, scripts, and tests. In the contracts, right click and hit new file. And let's create a contract called hello.sol. The first thing we're going to create is something called SPDX license. And the SPDX stands for Software Package Data Exchange, which is basically, hey, who can use this piece of code? Is this piece of code only for me and you cannot use it, or is it open source and public? And so that's what we're trying to answer here. Inside there, what we want to do is we say MIT, which MIT means it's pretty much open source. And within there, now let's create the contract by saying contract and giving it a name. I'm going to say hello. And then we use brackets to specify what code is going to go into this contract. And let's go ahead and create a variable called welcome. I'm going to say string public welcome is equal to hello world. What I did is I made a variable with a type of a string that is also public, meaning anybody can see it. And the value of that is hello world. Now you might notice that's giving you an error right here. Source file does not specify required compiler version, Pragma Solidity 0.18. That's right. I'm going to copy this section right here because you need to specify, hey, what compiler is going to convert my code, all of this code, into bits and bytes. And there's different compiler versions. And that depends on this Solidity compiler. If you look at the left-hand side, you have this little Ethereum icon. If you click on that, you'll see the version that we are specifying right here. And that's the one that you need to specify in your code as well. So just so you know, let's run this piece of code and see what happens. Let's go to this little compiler running. I don't know what this icon is, honestly. And inside here, we have the environment, which is where we're deploying this. It's a virtual machine. And all you want to do is make sure that this contract is called contracts/hello.sol and just hit deploy. When we deploy, on the bottom right here, you will see the actual contract, your code that was deployed on the blockchain. That's right. That's pretty crazy. And you will see that if there's this welcome variable that you created, interesting. If you click on that, that welcome variable will show you what value do you have in there, and that is hello world. Now, if you're answering Nas, what do we just do? What is this variables and what is this string and public and welcome? Well, let's talk about that next. Let's go ahead and cover variables. And you might be asking Nas, what is variables? And all it is simply to store your data in your program. That's it. There's different types of variables. We've got addresses, we've got strings, we've got integers, and we got booleans. And let's cover all of those. In the addresses, of course, as you can see, it starts out with the keyword address. That one is an address of your Ethereum address, for example. So that could be an address of your crypto wallet, could be an address of a smart contract. Again, because we're working with blockchain, then, of course, we got strings. Strings are pretty important because they represent just simply text. Yes, it's just a string. And of course, you specify it by simply saying, hey, string, then the name of that string, and then the value for that string. That's also very useful in many different places. And then with strings, we've got booleans, and booleans is, hey, true or false. And that's very important to say, hey, if currently, for example, something is true, then do this. If it's false, then do that. So that's why we use those. And then, of course, we have integers, and those are really important because integers are the building blocks of our programs. You're going to have numbers in your program, like it or not. For example, for an NFT project, let's just say you have a max supply of how many NFTs you have in the collection. And so we specify that max supply by giving it a name, giving it a value of 10, and then saying, hey, this is a uint of 8. But you might be asking, Nas, what is this uint 8, uint 256? Uint 8, uint 256 is the difference between how big the numbers can be. The larger the number, the more space it takes up in your memory. That's right, think of this as memory. The smaller the number, the less space it takes up in your memory. For example, here, what do you think 1 days is? Well, 1 days actually represents a timestamp, which is actually a really big number that is saved in this uint 256. Check this out. If you look at it right here, we have this wait time of 1 day, yes? And if we actually get the output from a smart contract, you see the number is 86400. And this is simply just a number in seconds of 1 day. That's all it is. It says how many seconds there are in 1 day. And that is stored in type of uint 256. That makes sense? And if you're thinking about, hey, how many uints are there? Well, there's a ton. We got uint 8, we got uint 16, we got uint 128, uint 256. And again, these are depending on how much storage they take up. 8 bits, 26 bits, 128 bits, 256 bits. And on the right side, you'll see if you have uint 8, your max number could be 255. If you use uint 16, your max number could be 65,000. If you use uint 128, your max number, well, I don't even know what this number is, but it's pretty big, okay? And then you got uint 256, that's an even larger number. That's like a dynamo number. So just keep in mind when you create your applications, depending on how large your number could be, you have to specify that. Let's go ahead and build a calculator with Solidity. Here are the things that we need to go ahead and create, which is we need to create a contract called calculator. We need to create a result variable to store the result. Then we need to create 3 functions, one being add, subtract, and multiply. And then finally, we need to create a function called getResult to give us the answer of the addition, subtraction, multiplication, all those cool things. And then finally, we'll deploy our smart contract. And then congratulations, you can pat yourself on the back. So of course, let's go ahead and open up Remix IDE. Now, before moving forward, I highly recommend you click the link down below in the description for the GitHub repository that has all of the exercises and the solutions that we will use in this course. So all you have to do basically is click on that link again, and then what we're going to see is of course there's a thumbnail, and then as you scroll down you will see all of the lessons numbered 1 through 29 so far. And every single exercise has either slides, which links directly to the slides of the presentation, or has also a link to the exercise, as you can see right here, and the solution. If you click on the exercise, it takes you to the exercise, and then if you click on the solution, it takes you to the solution. Now, we want to import this into our Remix IDE so it's easier for us to use. So click on this Git code button right here and hit download zip. Click on the download zip, and it should download the zip folder to you on the bottom. Once you've done that, you want to click on the zip folder to unzip it, okay? And you should see this Ultimate Solidity course main, okay? Once you have unzipped that folder and you have a normal folder, go to your Remix IDE, and here is our Solidity Learning workspace. All you gotta do now at this point is click on this upload folder button, not the upload file, the upload folder that looks a little bit like that, okay? Click on the upload folder. By the way, make sure you are in the contracts folder. Just make sure it's like that, and then click on the upload folder. Beautiful. Select your Ultimate Solidity course for complete beginners folder. Hit the upload button. Hit upload button, and there we go, my friends. There is your exercises. There is your solutions numbered 4, for example, through 29. Yes, some numbers are skipped because we don't have exercises for certain lessons, okay? But you can go one by one, 4, 7, you know, and so forth, and so forth, and so forth. And they directly correlate to the numbers that are here. And that's pretty much it. Once you're done, you can actually work with them. So for example, like the calculator exercise is right here. So here's your calculator exercise. And now you can directly work with this Solidity Smart Contract and finish it. That's it. Let's continue with the video. Remix.ethereum.org. And what you want to do is right click on the contracts folder and then hit new file. In the new file, we will create calculator.sol. The first thing we usually do is add the ASPDX license MIT. Then we want to use Pragma Solidity. There we go. Go ahead and save that. To specify what version we want of the compiler we want to use. And let's go ahead and create our contract called calculator. And here are our things we need to do. Make a contract called calculator. Done. Create a result variable to store the result. As we've learned before, to create a result, but you do uint 256 because it might be a big number. And we give it the name result equals to initially going to be 0. Now, it is all good and dandy, of course, to have a result, but what can we do with it? Well, to do something to it, we need to create something called functions. And let's just try out one function first here. To create one function called add, we will say function, add, and in that function, we're going to add to the result. So for example, we can say result plus equal 1. There we go. And this function will go ahead add 1 to the result. Now, of course, this has an error because you have to specify the visibility, as you can see right here. So to do that, we just simply say add public, meaning it's a public function and anybody can see it or even use it. That's what that means. That's it. You've created your own function. But what is a function? Let's talk about that. And so a function is simply just a repeatable task. For example, this function is just doing a repeatable task of push-ups. And this is the structure of a function. You usually start with a keyword called function to tell the compiler. And then we give it a name called get. And inside the parentheses, you specify here are the parentheses. This is where your parameters will go. Then we will specify basically what visibility and what type it is, in which case it is public, and view, meaning it simply just returns something. And then we specify the return type because you have to specify in Solidity what are you returning. An integer, a string, a number, a boolean, whatever it might be. Solidity works like that. And then inside those brackets is where you actually specify your logic. So in our case, of course, we have a function. We have the name called add, parameter that's nothing inside so far, and it is a public function, and it basically simply adds to it. So it doesn't return anything because all we're doing is adding to a number. And plus equal to, that is simply an incrementer. It's the same thing as saying result is equal to result plus 1. Now, one thing we want to do is we want to add a parameter because we want to specify what number we want to add. In this case, I'm going to specify a number, a uint256 number. And that's just going to be the variable called num. Again, it's a placeholder variable. And then we're going to use that num instead of the 1 to add to the result. Now what you can do is specify, hey, I want to add 5 or 10 or 15 or 20 to the result. That's the whole goal behind that. Let's now go ahead and create the subtract function. Subtract. We're going to create another uint256, a uint256 num parameter. Give it a public visibility, correct? And then we'll say result, same thing as in we do with plus minus, we do minus equal to num. So let's just say if the result currently is 10 and we specify num as being 5, then 10 minus 5 is going to be equal to what? 5. Hopefully you said that. Hopefully we don't have to relearn math, guys, okay? Then the third function is going to be what? Multiply. If you want to go ahead and try that by yourself, then just pause this video. Let's do this together. Function, multiply. Then we specify the parameters, correct? Or the attributes. And I'm going to say uint256 num. It's a public function. And all we are doing inside here is multiplying. So we say result multiply equal to, this is what you do for multiply, times equal to num. So again, let's just say your result currently is 5 and your num is currently 5 as well. It will do 5 times 5, which is going to be equal to 25. Yes, that's going to be the result of that functionality. And then finally, the last function we need to add is called get to get the result. So let's do that. So we will say here, function get, there we go. There's no parameter here because all we're doing is return getting a number. So we don't need to specify that. It is a public function because anybody can use it. And we need to specify what is returned from this. So we say returns a uint 256. That's right. And now we just simply return result. Now it does give us a warning, meaning, and that says the fact that this can be restricted to a view function. And that is because we're not changing the state inside this function. So we can specify public view returns uint256. And that just simply tells the compiler here, we're not modifying the data, the variables. We're just taking the data and then showing it to you. That's it. All right, good job. So we've done that. That's a check mark. Boom. This is a check mark. This is a check mark. At this point, let's go ahead and deploy our calculator. Go to the Solidity compiler right here and just make sure you've compiled everything. You don't have anything that's weird. And then let's go to the deployment section, which looks a little bit like this. Make sure your environment is selected to Remix Virtual Machine. You have the calculator.sol selected and just hit the deploy button. And there is your deployed contract. And you notice there what? You notice we have 3 functions, add, multiply, subtract, and then a 4th one called get. So let's test this out. If we go ahead and I add to a number, let's just say, and I say, hey, let's add 5, and I hit transact, what do you think the result will be? Well, hopefully you said 5 because 0 plus 5 is 5. But now let's say we multiply 10. So now we say, hey, multiply this by 10, and I hit transact. And now what do you think the result is? 50, because before the result was 5 and now it is 50. Hopefully that makes sense to you, right? Now let's do subtract. Maybe we want to subtract, I don't know, a 10. So subtract 10. What do you think the result will be now? Well, hopefully you said 40 because you can see right here, it is 40. This result is saved on the blockchain. And all we're doing is adding to it, subtracting to it, and multiplying to it. And that is it. Now, again, very important. I want you to understand the fact that this num, that's your parameter that gets put from the function. That's right. Imagine a vending machine. You put what? You put $1 and you get something out of this. You put $2, you get something out of that. Then you think of parameters as just simply in a vending machine where you put your cash in there, right? You're specifying the parameter. The machine will give you something as a result. Nas, how am I supposed to deploy Solidity code to the blockchain? It makes no sense, man. That's pretty simple, my friends. All you have to do at this point is make sure you have MetaMask installed, as you can see right there. If you do not have MetaMask installed, make sure you install that. There's a bunch of videos on YouTube showing you how to do it. As you can see, I have a MetaMask right here. And a few things I want you to do. If you've installed MetaMask and it's in your extensions, make sure you go into the extensions in Chrome and make sure you pin it so it shows up on the top right here. And once you've done that, make sure you have test networks turned on. If you don't see Gorilla or Sepolia, for example, then all you have to do is go to your little screen, go to settings, go to advanced, scroll down, and make sure you have show test networks as turned on. And once you have that, hit X, and you should see Sepolia, Gorilla test networks in there. You want to select right now Sepolia because it's just better than Gorilla. And in Sepolia, once we have that, you want to get now test coins. And no, that doesn't mean you get free money. It doesn't work like that. That simply means that you can get test coins for testing your code. To do that, go to Sepolia faucet, and you should be presented with the Sepolia faucet from Alchemy, I believe. So click on that one, and you might have to log in. Yes, I know, that's okay. Just hit login. I'm already logged in. I just hit login, and you want to enter your wallet address. Go to MetaMask, and you see your wallet address right here. It says account 1. That's all you got to do. Just go ahead, hover over that, hit copy, paste that into the input, and hit send me ETH. Now you do have to specify I'm not a robot. Hopefully I'm not a robot, even though some people say I am. Click send me ETH, and hopefully you get the cash. Let's go. It's not real cash though. Anyways, go to MetaMask and you should see 0.5 Sepolia. I have 0.51. Go back to Remix now, and here's our calculator code. And let's deploy this calculator code to the blockchain. That's right. Currently, you have deployed contracts right here. And you want to clear out any deployed contracts by simply hitting clear instances list inside the top environment. And from there, select injected provider MetaMask. It pops up a window. Make sure you select the correct account you want to use. Hit next and hit connect. That's very important. Once it's connected, you should see Sepolia right there. And at this point, all you have to do is just simply hit deploy. Deploy. MetaMask popped up. You can see this is how much it's going to cost you. Hit confirm. And on the bottom, you'll see view on Etherscan. Hit that, and you will see your code deployed to the blockchain currently on Sepolia network. There it is. And there's your contract. So you can actually click on this contract, and there is your contract instance. Now, of course, you can't really see your code because you have to verify it, and we'll talk about that a little bit later. And even, for example, if you want to make certain transactions, go to in Remix. If you click this little arrow icon down, you can actually add numbers. So for example, I can add 5 and I hit transact. Of course, that means you have to pay for it. That's how blockchain works. Hit confirm. And then let's just say you want to subtract 2 now, hit transact. Again, it's going to ask you to confirm. There we go. And of course, you can actually view each transaction on Etherscan that's being deployed. As you can see, every time you get a green check mark, it means all is good and dandy. And now if we do get, check this out, our result is 3. There it is. Now, if you're wondering now, that this doesn't make sense. How come I had to pay when I was doing addition multiplication and I did not have to pay when I was doing get? That is because when you make state changes, when you change data on the blockchain, you have to give it money. However, if you get data from the blockchain, you don't give any money, you just do it for free. So there we go. Let's talk about visibility. That's right. You can't see me, now you can. You can't see me, now you can. Okay, as an example here, in our calculator smart contract, we used public. That is visibility, meaning this function is publicly visible and anybody can use it. So let's talk about the different types of visibility that's out there. The first type is going to be public, of course, and that means it can be used internally or externally. Your MetaMask account can use it. Other contracts can actually call this function and then use this function externally as well. Anybody. So it's publicly available for anybody to use. The next one that we have is private, and that can be used within the contract only. When you have it on the blockchain, this function is not visible for you to click on or to use. It is only to be used within the code itself. And that could be something important because sometimes you don't want all your functions to be visible and to be used every single time. You only want to implement some logic, for example, a private variable or a private function like this. The third one is going to be called internal, and that one can be used within the contract and other inheriting contracts. This means you cannot still use it externally. That's right. For example, your MetaMask account will not be able to use that function or that variable. However, other inheriting contracts can. Let me explain. We have two contracts right here. One is called the basic calculator. Another one is called the advanced calculator. The basic calculator has two functions, add and subtract. Now, an advanced calculator has multiply and divide. Now, what you notice here is that there are two different contracts, but this contract is inheriting the basic calculator. What does that mean? It's like, hey, I am basically your parent. The advanced calculator is saying, hey, basic calculator, you are my child and I can use all your functionalities that you have. Calculator is whatever the contract you want to inherit from. And that means that this contract now can actually use these same functions and even these variables. And you'll notice result is actually coming from where? The basic calculator, but we're modifying it inside here. The result inside here, again, that's coming from the basic calculator and we're modifying inside this function. And it's all because they're marked as internal. And the performance operation, for example, this is an operation where you can perform different functionalities. You'll notice here, I know it's highlighted in a weird way, but they use functionalities like add and subtract, and that's coming from where? Directly from where? From add and subtract from the basic calculator. For example, our calculator, if we mark this internal, this function add to internal, and we deploy it, let me go ahead and deploy this to not the MetaMask, but deploy it just to Remix VM so we don't waste any money. Go ahead and make sure to select the Remix virtual machine, hit deploy, and you'll notice something. If you now go to your contract, if you click on the drop-down arrow, the add is no longer there. That's right, because we marked it as internal. It can only be used within the contract itself. But you see other ones that are marked public, well, you can actually use them. The fourth one and the final one that we have is going to be external. And that one can only be accessed from external contracts and accounts. So for example, you're saying here, hey, only external contract or external accounts like your MetaMask wallet can access this function. And why do we do this? Because you can say, hey, why don't we just mark this public in that case? We do this to actually save on gas fees. We do this to save on gas fees because then the compiler does not have to allow it to be used internally. You're saying, hey, this function add is going to be used externally anyways. So why mark it as public? Instead, mark it as external because it's only going to be used by the MetaMask wallet outside by other users. And so that just saves on gas fees. So your current contract can be completely changed to actually use this external functionality right here. If you change the internal to be external and we deploy this, let's go ahead and click the X and hit deploy. You'll notice that you can actually see add, multiply, subtract, meaning I can use it externally, but I cannot use it internally. So if I try to use it internally in this contract and I try to say here, I'm going to say add, and I'm going to pass in the num. You notice here that it actually gives me an error because it says undeclared identifier add is not visible at this point because add is an external function and not an internal one. By the way, if you're a business owner that's looking to build your own Web3 project, an NFT project or an NFT marketplace, I have a company where we have helped many clients turn their ideas into a reality. We will help clients like this build their own NFT project, and even a client like this create their own NFT project that later on generated over $500,000 in NFT sales. We do everything from Web3 development to smart contract auditing to amazing UI UX design. And so if that's something that you're looking for, or maybe you just need consultation on your future Web3 project, go ahead and schedule a call with me in the link down below in the description, and together we'll figure out how we can turn your idea into a reality. Let's start out with a basic Twitter smart contract. All we need to do to start out is basically create a new file inside your contracts folder, give a new file, and just say twitter.sol. As we all know from start, we usually we need to add the MIT license. So let's go ahead and do that. And then of course we need to add a pragma solidity, so to specify what version of the compiler we're going to use. In our case, it is pragma solidity 0.8.0. And here's the things that we need to create to make the whole Twitter smart contract work. Let's create the first Twitter contract. I will say contract Twitter, open up the brackets, close the brackets. That's all done. Great job. Next one is going to be create a map between user and tweet. Now we need to do that because we need to somehow save that tweet and then tie that to you, the user, so there's that connection. Now you might not know what a mapping is, but let's just do that and I'll explain what it is later. So we will say mapping, and it's between a user, and the user is usually always the wallet address to a string, because a string is the tweet. So when you say something, it is a string. And then this will be a public mapping because it's a public variable, and we will just call it tweets. Now we're going to create a function to create the tweet. So whenever you tweet something, we're going to create that tweet. So we'll say function create tweet. And for our input, what do you think our input is? When you type, what do you type? You type strings. So we say string underscore tweet right there. It's a public function because anybody can use it. And then in order to save this tweet right here in the tweets mapping, the way we do it is we say tweets, square brackets, and then the key basically is the address. So we'll specify here message.sender is equal to underscore tweet. Now you're like, Nas, okay, hold the phone. What the hell happened here? Okay, hold on. Don't worry. Now you might see an error that says string tweet, data location must be memory. That is because we need to specify that this is a memory. What that means is it's storing this tweet variable, this tweet parameter in temporary memory, and that's what we're going to use inside that function. It's very important because a string takes up a lot of memory in general. So you have to tell Solidity, hey, store this in temporary memory, and then use this in a function. Next, you might be asking, well, Nas, what is this message.sender? That's right. Message.sender is coming directly from the blockchain. Whenever you use your MetaMask wallet, for example, like this, okay, and you interact with the blockchain, your address and other information is stored inside this message object. And so as a result, it is actually available to you and to the smart contract. And one of the properties it has is sender. Well, that is simply your wallet address. That's right. And so we're saving your wallet address as a key that has a value of your tweet, meaning you tweeted this tweet. And finally, a third question might be like, Nas, what is a mapping? This is so confusing, Nas. I don't get it, okay? Well, let's go through that. So what is a mapping in Solidity? Well, it is hangers. Now, it's not actually hangers, okay? But it is very similar to that. Okay, imagine mapping like hangers. You have these hangers for Monday, for Tuesday, for Wednesday. Your key is your hanger. So for example, Monday could be a key. And then the value is whatever you put on the hanger. So that could be any type of clothes. In this case, it is this, okay, come on, right here, right? That's your mapping. Monday for key, this is gonna be your value. Same thing goes for Tuesday. That's a key, that's a value. So for Tuesday, I have a different type of shirt. And then for Wednesday, I have another different type of shirt. Again, the hanger is the key. Whatever's on the hanger, that's the value. There we go. The most important thing you wanna think about mapping is key and value. Key is a number, represents some kind of information that is very unique. A value, however, represents the data, which could be, for example, this could be like a code. Another example of this could be a student ID and a name. A student ID is your key, could be 0, 1, some random numbers. The value, however, for that is a name, could be Nas, Tony, Larissa. And so what name belongs to what student ID? And that's what a mapping is used for. Another great example could be a key value pair between address and name. So this is more of a Solidity example, okay? Let's just say you create a sign-up contract. You will create a sign-up contract where you have the address that maps to a name or maybe to an email. And that is important because one, every single address is going to be unique. And two, it is extremely fast at accessing that address and finding that address. And so to give an actual example of how we use it, here's an example of a contract that uses a mapping. You can see we create a mapping here called address and uint. So basically, we're going from an address, like a wallet address, to an integer. And we're saving that in a variable called myMap. Basically, at the end of the day, it looks a little bit like this. Imagine you have the key, which like is 0, or 1, 1, or 2. And so what happens is that that is saved directly to some value like this. Value. I know it looks a little bit horrible, but value. And imagine that it has a connection between the value and the key, or we call it, in this case, could be the address, or in this case is the number. And so it's amazing for storing data because one, it's extremely fast at accessing that data. In this example, we have the variable called myMap. And what we're doing here is, let's just say we want to save some data in this mapping. The way we do it is we specify, hey, use the keyword myMap, which is the variable name. And then we use these square brackets to say, hey, here is my key. And in this case, it is an address that we're passing into this function called set. It's an address of some kind of a wallet address. Then the value is what's on the right side of the equal sign. In this case, it's an I, which could be an integer or maybe something else even. And so that saves the data from an address to an integer. Now, let's say you want to access that data. We've saved it. Okay, great. How about we access it? Then to access it, we have this get function, of course, that we created ourselves. And all we have to do is specify the mapping variable, which is myMap. And in the square bracket, specify the address. And so imagine here, it's going to try to find some kind of an address or this address, depending on what the input is. And once it finds it, which is pretty much instantaneously, it's like, okay, here is the value. And so that's what's going to output inside here when you return that number. Hopefully that makes sense. And of course, you can also delete a mapping as well. So let's just say you want to delete a record. You say delete myMap and then the address. So the most important thing to understand is the address, this key, is the trivia part that makes everything work. It's like a key that opens the door. What's behind the door is your value. That's right. When you open this bottle, it's inside here is your value. It is your water. It could be Jello. It could be Gatorade. It could be, anything else. Hopefully that made sense. So yeah, that's mapping for you. Let's continue on with our Twitter smart contract. As you can see right here, we're saving the tweet in that mapping. Again, it's saved. The key here is the address. The value is the string, your tweet. We have a function called create tweet that creates the tweet and saves your tweet in the tweet mapping just by using the square brackets. Now we need to get the last function that is going to be to get the tweet. Let's create a function called get tweet, and then the input that we need to do is get based on what? In our case, based on the address or the owner. So I'm gonna say address underscore owner. This is gonna be a public function. And what are we returning? Well, we are returning your tweet based on the owner. So to do that, we say tweets, and we're trying to find the tweet of the owner. So I'm gonna say square brackets underscore owner. I will say return tweets square brackets underscore owner. Again, we're trying to find the tweet of that owner. Now you might see that says an error, different number of arguments in return statement than in return declaration. That is because when you in Solidity, if you are returning something, it's very important to specify what type are you returning. I will specify that by saying returns a string, but not just a string, but a string memory. Reason being is because we have to store this string temporarily before we return it. Now we specify memory because you have to tell Solidity where to temporarily store that data. One, for gas efficiency purposes. So for example, if you have tweets like this saved in that map, and you have tweet 1, tweet 2, tweet 3, and so forth, you have to say, hey, save this tweet in a temporary value. So this will be tweet, and that is what gets returned in the function. And this is necessarily for only complex types like strings, like arrays, and so forth. Now we still get an error that says function state mutability can be restricted to view. That is because inside the public, I can say public view returns string memory. And that's also important because you're telling Solidity here, because in this function, we're not really modifying any data. We're just simply getting data and returning that. And again, this allows Solidity to be a lot more gas efficient yet again. You're simply returning some data. And so you have to tell that to Solidity. There we go. And so there is our basic Twitter smart contract. Let's mark this as complete. Let's mark this as complete right here. Let's just test this out and see what happens. Again, we're going to go to the deployment section right there. Click on that. We're going to use our Remix VM merge right now because it makes things easier. And then just hit deploy. And of course, once you deploy on the bottom, you should see your smart contract right there. And you can see there's a create tweet, a get tweet, and of course there's a tweets mapping. So to create a tweet, let's just say we say hello world, and we do create tweet, and then our tweet is saved on the blockchain. That's how cool that is. Now let's go ahead and get the tweet based on some kind of an address. And what is our address? It is this one right there. I will copy this to clipboard, paste that in, click call, and there you go. It is stored on the blockchain, my friends. Hello world. How cool is that? Let's talk about arrays, the most important thing in coding. And honestly, I have no idea why I picked Winnie the Pooh, but all I can tell you is that, it's funny. But however, even though Winnie the Pooh has nothing to do with arrays, but the actual honey does, because if you have many bottles of honey, that is an array. Again, a list of things. So if you want to think about arrays in general, it's just simply a list of things. As an example, the way we think of an array in coding world, including Solidity, is like this. You might have an array, for example, of names, and think of it as simply just boxes. And here you have this one big box that stores all these different boxes. For example, you have Nuz, Victoria, Dan, Harry Potter, and these are just simply a list of things. So if you want to store a list of something, you would store it in an array. But the interesting thing I want you to pay attention to is actually the index. Why? Because it's how we access an array. Think of it as the key that opens the door to the individual values of that box. So for example, this key is 0. Then we go 1, then 2, then 3. And in coding world, it always starts from 0 and it always go incrementally to the right and increases in numbers. So just keep track of, think of that. Now, in terms of how do we actually use it in coding, here it is. Here, for example, we're creating a contract called an array. And inside here, we're defining arrays in different ways. When we define an array, you want to specify number 1. What type of an array is it? Is it a string? Is it an integer? In this case, it's a uint. And then to say it's an array, we specify, hey, we use the square brackets. And then you specify its visibility. In this case, it's public. And then, of course, you give it a name. And that's pretty much it. Once you have that, you're all set. If you actually want to provide data, however, let's just say you want to initialize that array with some data, you would initialize it like this, square brackets, and then you specify a list of things. In this case, it's a list of numbers, 1, 2, and 3. Now, this is just one way. Now, this is an array that will continuously grow. However, we can also create fixed size arrays, meaning, hey, I'm saying there's only a maximum of 10 elements in that. For example, here, uint 10, this means there's a maximum of 10 elements in that array. This doesn't mean that 10 is in the array. I don't want you to confuse with that. No, no, no. I want you to think about it as just 10 elements in there. And they're all initialized to 0. Here, for example, we are initializing with 5 elements, and this is a type of string of names. Now, the question you might ask, okay, how do we use these arrays? So here I have an example of an array example. Again, public dynamic array, we have a fixed array, and of course we have to somehow add information to it, just how you have to figure out how to add more water into this bottle. And the way we do that is we just simply use something called .push. So we take this array name right there and we do .push to push a value into that array. And honestly, that's pretty much it. It doesn't get easier than that. Now, to get the data for an array, for example, you want to get some data, we use array at position I. So remember those index values we talked about? Like, for example, 0, 1. The way you access Nuz is by saying, hey, give me a value at index of 0. So in our case, for example, give me the value at index of I that I pass into the function. And that, my friends, are arrays. let's go ahead and apply an array of tweets to your current tweets mapping, because as you know, just simply having one tweet is no good. Right now, the way we have our mapping is an address maps to one string, and there's no point of just having one tweet. We want to have a list, an array of tweets. So to create an array of tweets, we need to go ahead and make this not just be a string, but say a string of arrays, and that changes things now. And so now, instead of saying tweets message.sender is equal to tweet, we say tweets message.sender, and then we use what? The dot push to push a tweet into the array. So dot push underscore tweet like this, and that will go ahead and add a new tweet into this array of tweets. And so now this of course changes as well, because the get tweet function will get one tweet. But of course, we don't just have one tweet, we have an array of tweets. So to change that, we have to specify an index value, in which case it could be a unit value of underscore I for the index. And now we get one tweet at a specific index. So for example, if I do square brackets of underscore I, this will get me basically a tweet at some position of I, 0 or 1 or 2 or 3. So let's just say I have this array of tweets stored in an array. If I go ahead and input uint of 0, it will get me what? It will get me yo. If I go ahead and input I for 2, let's just say, it will get me good morning. Because again, we're adding tweets incrementally at position 0, then 1, then 2, then 3, and so forth, and so forth, and so forth. Now, you might be asking, Naz, how can we get all the tweets all at once? Well, we can create that function as well. So let's create a function called get all tweets, and this get all tweets for specific owners. So let's just say we're gonna pass in what? The owner underscore owner. And at this point, we're not passing in an index because we want to get all the tweets. This is going to be a public function. It's going to be a view function, and returns what? Not a string, but an array of strings. That's right. And again, this is a memory because we need to store this temporarily and then return it. And inside here, we return what? Return tweets at what? Underscore owner. And that is it. This will get me all the array of tweets that I have saved previously. Again, the big thing that you will probably see is the fact that we changed from the return from just number of string to an array of strings, and that's the big change. Let's go ahead and test this. Let's go back to our fancy handy dandy deployment section. Again, make sure your Twitter.sol is selected, your remix is selected, and just hit deploy. I would suggest you clear out any other deploy contracts you have, because you need to redeploy your contract every single time that you make a change. So hit deploy and then scroll to the bottom. You should see your actual contract. So let's create a few tweets. I'm going to say here, yo, okay. I'm going to say another one called hello Twitter. Create tweet, of course. Then I'm going to say another one, this is Nas. This is Nas. I'm going to create tweet on this one as well. So I've created 3 tweets. How many indexes do we have? 0, 1, and 2. And so let's get all the tweets for a specific owner. If I go ahead and get my account address right there, just click on copy, and I paste in my account, and I click call, you will see I get an array right there. Look at this, an array of strings. This is your tweets. Yo, I spelled hello wrong. Twitter, and then this is Nas. However, I can also get one tweet. For example, here. Again, let's pass in our owner, and then let's try to get the first tweet we ever made. And that index value, of course, is going to be 0. So call that, and of course, we get yo. If we, for example, pass an index value of 2, we call that, we get this is Nas. If you pass in an index value that does not exist, for example, let's just say 10, then you will get what? You will get an actual error right there, because it says revert. It has been reverted because you're trying to access an array outside of its bounds. This is how we use arrays in our smart contract. Pretty cool. And so let's go ahead and mark this to be done. Boom. Ayya. Let's talk about structs in Solidity, because they are extremely important. That's right. Hi, my name is what? My name is okay, yeah, I know. Eminem, I love Eminem. But the reason why I have Eminem here is for one really good reason, because He is saying my name is. He is defining himself. When you think of structs, think of as what do you define yourself as? And here's an example of what I mean by that. Let's take a Tesla. When you describe something like this, what would you describe, for example, like a Tesla Model Y? In this case, well, you might describe what? The model. You might describe the year of the car. You might describe the color of the car. And so think of these as almost keys. Again, maybe it reminds you a little bit of the mapping, but think of this as more so a description type situation. And the value here is, for example, Model Y, year 2023, color blue. It is what describes to Tesla. Let's go ahead and take a real example. This is me right there. The first thing you want to do when we create a struct is we define a struct. And the way you define a struct is like this. You say, hey, struct, you give it a name, could be any name, and then you define what parameters are in the struct. So these are your keys. For example, model, year, color, mileage, VIN. And here, for example, is we specify like an array. And again, this is optional if you want to save a bunch of structs in an array. Now, since we defined a struct, let's go ahead and actually add to the struct. In this case, it looks a little bit like this. You have to add the data. So if we had our struct right here, we could have a function, for example, like add Tesla, where we have parameters. And when we create one, here's how we do it. We say Tesla, so we use the struct name, new Tesla, this is like almost like a class, is equal to Tesla, and then in these curly brackets, you actually give the key and value pairs. So model is the model, and then the model is this model, the value is coming directly from the parameter. This year, for example, is coming directly from the parameter. So you're saving that data in a structure type format. So model would be like Model Y, year could be like 2023, color could be like blue, mileage could be something else. And then since we create a structure, think of it as like a defining structure, then we're pushing that structure into an array. And you don't have to always push into an array. Sometimes it could be in something else. And so there, my friends, this is your struct. So of course, it is all good to have an array of tweets, but tweets have more data than just content. It has the author, it has what? The date when the tweet happened, it has things like likes and so much more. So let's save that data now inside the blockchain. And to do that, here's what we have so far. This is our tweets, of course, that we've done previously. And in order to add more data, we're gonna use structs. That's right. Here are the things that we need to do. Number one, we need to define a tweet struct with author, content, timestamp, and likes. Number two, add the struct to the array. This struct will define a tweet that will have multiple points of data. And of course, then we need to test the tweet. Part one, let's define our struct. So define our struct. To define our struct, we say struct. Let's give it a name. We say tweet is our struct name. And inside that, we specify what data, what keys are we going to create. And so, of course, we see here we have an author, content, timestamp, and likes. And let's go ahead and add those. So the first thing is going to be the author, and that's going to be the wallet address. So I say here address, author. Second thing is going to be what? The content. That's right. So I say here string content, and that is the actual tweet content. The third one is going to be what? Timestamp. And so that one has that tweet been created. So we say here uint 256 timestamp, because of course, as we know, timestamp is represented by what? By a number. And then finally, the last thing we're going to represent is likes. How many likes does that tweet have? So I'm going to say here uint 256, because of course it's going to be a number, and we say likes. And there we go. We've defined our struct inside right here. Now, of course, it's all good and dandy, but we need to now use it. And right now, the way we use tweets is we simply use it as a string. Well, how do we now use structs instead? To do that, all we do is simply replace string with what? With the tweet struct. And this tells us now that this mapping has not an array of strings, but instead an array of structs that have all of this specific piece of content. But that also means what? The third thing, we need to go ahead and add the struct to the array. So right now, whenever we create a tweet, okay, let's say you type in a tweet, blah, 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 hello world, whatever it might be, you have to now add this struct itself. The first thing we need to do when we create a struct and we want to add it, let's just say to a mapping, we need to create an instance, we call it, of that struct. So what I will say here, tweet memory, new tweet is equal to tweet parentheses, and then inside the brackets, we specify the content. So the first content is going to be the author. As you can see, I misspelled author completely. So hopefully you fixed that and you caught that. So first one is going to be the author, like so. And what is the author? Well, the author is the message.sender. That is the address. So I will say message.sender. After our author, we need to add what? The content. And what is the content? Well, that is the actual tweet that we want to create. So I will say here content, and we're going to use the data from where? The underscore tweet. So we'll say underscore tweet, like so. Then of course, the third thing is going to be the timestamp. So I will say here timestamp, and the data for that one is coming directly from the blocks. That's actually available to us directly. So we'll say block.timestamp. And finally, the last piece of data we need to save is the likes. And usually, if you think about it, when you go ahead and you're creating a tweet, usually you have no likes. You've got zip. So we will go ahead and make those likes initially to be what? 0. Now, of course, you do have a little bit of an error. And do not forget to add a semicolon in here. That's pretty important. But you do have an error right here, mainly because of what? Because looks like, let's see. Member push the not found or not visible after blah, 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 blah. Okay. That's because we're pushing right now a string. However, we need to push a tweet object. The tweet object is which one? This one. So I will say here, instead of underscore tweet, we say new tweet. And that's it. We're pretty much all good. Now, if you're wondering what is this memory for, that is because whenever we create a new instance of this structure, you have to tell Solidity here, save this in temporary memory. That way, when you're done with this function, you can remove this memory, and then Solidity does not have to worry about anything else at that point. So that's why we do that. Of course, we're not done yet. Not done yet because things change now. When you get tweet, what says here, we are returning what? A tweet, some kind of an index of a tweet. The problem is this, in the function, we say, hey, we are returning a string memory, which is not correct. We're actually returning what? The tweet object. So we say here returns not string, but tweet. And then of course, inside here, when we return all tweets, we're not returning an array of strings. We're returning an array of what? Array of a tweet structs. So we'll say tweet, and that's pretty much it. So we're all good on that side. I love that song. Let's go ahead and now deploy this. Do not forget, let's go to our handy dandy deployment section. Click on that. We're going to use our Remix virtual machine merge. And let's go ahead and deploy. And make sure you delete all your previous deployed contracts if you have anything underneath here. Let's go ahead and hit deploy. Boom. And here is your new deploy contract. Okay, let's try and create a tweet. So I will say here, yo, transact. It's been created. Okay, great. Now let's go ahead and get the tweet of me. So I will go ahead and copy this account, paste this account, ID of 0. How do you think this will look like if I hit call? Oh, there we go. Look at this. It looks a little bit weird, but it's a tuple, the way it's returned from for us. But you'll notice actually the content of this tuple. Here inside here, we have the address. Then we have what? The content, which looks like a little bit like yo. Let me go and zoom in. It says yo. And then finally, we have a timestamp, which is this one. And then the last thing is going to be tweets, which is likes, which is 0. So a little bit hard to understand, but whenever you return it, you will know exactly what you're talking about. And there we go. That's pretty much it. There's our struct. Pretty useful, huh? You shall not pass. That's right. That was said by the require statement. Require in Solidity. What does that mean? Require is basically a way to create conditionals in your Solidity code. So the way you want to think about it is the following. You have a condition that you want to be true. If that condition is true, then your program will continue to run. However, if that condition is false, then your program will stop and will simply just revert. And the way it looks like in the actual code is like this. So let's say we have this function called mint for minting NFTs. And we have this require function that looks a little bit like this. And it has two parts. The first part on the left is going to be the conditional. And the second part on the right is going to be the error code. So meaning if this conditional is false, then we spit out this error code. And the logic behind this is here. We're trying to mint some number of NFTs, let's just say. And the maximum amount we're allowing people to mint is 3. Meaning if you're trying to mint more than 3, then good luck, buddy. You are not allowed. And so that is the big difference here. Basically, if you're not allowed, we're going to give you an error that says no more than 3 allowed. And at the same time, we're going to exit the program and basically revert the whole transaction on the blockchain. However, if this is true and everything's all good, and let's just say that your input is 1, in that case, we're all good, and we're gonna mint the NFT. We're gonna mint 1 NFT, and that's it. And that is how require statements work. It is pretty simple. It's just a simple if and else conditional. If this is true, we continue. If not, peace. Let's go ahead and limit the amount of characters you can add in to a tweet. And of course, we are going to use the require statement to limit the length of the tweet to be only 280 characters. So how do we do that? If we scroll down to the bottom, of course, we need to limit it when you try to make a tweet. And as we all know, with the require statement, you need to create a conditional. And what does a conditional look like? It looks like this. If tweet length is less than or equal to 280 characters, then we are good. Otherwise, we revert. Let's go ahead and convert it to require statement. So we say require. The conditional get the tweet length needs to be 200 less than or equal to 280 characters. Now this is a tough one because I cannot just do underscore tweet, less than or equal to 280. It doesn't really work that way. You have to convert the string into something called bytes. So I'm going to convert this to bytes like so. And this tells us how many bytes each character takes up. Now, usually in ASCII, one character takes up exactly 1 byte. And so what happens on bytes, we have this option called bytes the length. That will give us the length of bytes. And if 1 byte is 1 character, then this will give us the exact number of bytes that is the exact number of characters. So on this conditional, we are making sure that this tweet length is less than or equal to 280 characters. Otherwise, the error code we can say is tweet is too long, bro. I'm just having fun with this one. And if the tweet is too long, then it will revert, go out of this function, and none of this will execute after that. Now, one thing we might want to fix is actually just change this to be a constant, and I will do that up top. I will say uint8, for example, because I know it's a small number, uint8. Then we'll use the word constant, meaning this value cannot be changed. Constant max tweet length is equal to 280. Now you notice that you will get an error because it's actually saying that uint8 is underneath 280 because I believe uint8, the maximum number is like 250, I believe. It's actually 255 now. So we will convert this to be uint16, and then that will allow us to be a much bigger number. And now let's go ahead and use this constant. I will say uint16 constant, and I will use it right here instead of 280. And now it will make sure that our tweet is less than 280 characters to be able to actually create the tweet. Let's test this out. I'm going to go ahead and deploy this using our handy dandy deployment section. I will remove all of our previous deployments and let's try to deploy again. So let's go ahead and hit deploy. There it is on the bottom. And let's try to create a tweet. So I'm going to say here, yo. Okay, that's my favorite word, yo. And of course, it has been created. But let's try to create a tweet that's longer than 280 characters. Let's use our handy dandy chat GPT to generate 400 characters of lorem ipsum. Copy this, paste it into the tweet, hit transact, and boom, tweet is too long, my friends. So you can see we're limiting that tweet to be 280 characters long. Now this is not a perfect limit because bytes is still a measure of how much space something takes up. And so for example, like a dot or a point can take up less the space than like a normal character like A or B or C or D. So it's not extremely perfect, but it works for now. And of course, if we try to get our tweet, let's go ahead and get our tweet by the ID of 0, and then the owner is going to be our account. Boom, hit call, and there is our tweet. Yo. Of course, the one thing I want to change now actually is I'm kind of getting tired of putting in the owner of the tweet to get the tweet. So why not we convert this get to tweet, because technically the person who's calling is the owner most of the time, correct? So let's just use message.sender as a way to get the tweet, I would say. So I'm going to say instead of underscore owner, I will say message.sender. I will remove this one. There we go. And I will go ahead and redeploy this. So we'll hit that big X button, hit deploy. Let's go ahead and check this out. I will create a tweet. Yo, hello, create tweet. And to get the tweet, I will just want to get tweet of ID of 0. I hit call, and then here is our tweet right there. As you can see, yo, hello. And that is it. What is a modifier? Is the question. And a modifier, my friends, is a building block. Have you ever played World of Warcraft? Well, I have not. So hopefully you understand this more than I do. But from what I know is that in World of Warcraft, you tend to build things on top of each other. You might have, for example, a house, you might have a building, and then you build on top of that. You build an extra room, you build this, you build a castle. And that is what a modifier is. It is building something on top of what you currently have. For example, it is a way to add behavior to a function. So what I mean by that is, imagine this. Imagine you have a function in Solidity and it has some logic, and it's minting NFTs, maybe it's adding a tweet, maybe it's doing something else, whatever it might be, and it has this logic. But you want to add a modifier that checks maybe, hey, in order for you to be able to actually access this specific function, you need to be an admin or you need to be an owner. There's some requirements that have to happen for this function to exist. And so that is where modifiers are really handy. You can insert this logic almost as like a separate little function into your current functions. So check this out. Here's an example of a modifier. In this case, we want to make sure only the owner can call the change owner function. Imagine you have a contract that can only be modified by an owner of that contract. And as we know right here, the owner is who? The owner is the person who created the contract. And that's the case because of this thing called a constructor. Constructor gets called when and only when, my friends, only when you deploy the contract to the blockchain. That is right. So in our case, we have an owner that is the person who deployed the contract, and we want to maybe change the owner potentially. We have this function to change the owner. Well, of course, not everybody should be able to do it. You should not be able just to go into any contract and be like, okay, I'm the new owner, and set yourself as the owner. That's not good. It's like making yourself an admin. And of course, that is very dangerous. So we have this modifier that says, hey, require that only the message.sender, the person who's trying to call this function, is actually also the owner. Otherwise, you are not the owner. And the way it usually starts out with is you have the keyword modifier. Think of it as like the keyword function, but this is a modifier. And then you give the modifier a name. It could be any name. Then you have parentheses for parameters, but most of the cases, it could be empty. And then you have brackets, of course, where your code goes. In here, you specify, okay, here's some extra logic code that I want to add. In this case, it's a require statement. Now, it could be different things. Then, what's really interesting is this point right here, this underscore. This underscore is actually, this tells Solidity where your other logic is gonna run. So for example, if you're looking at this function change owner, this says, hey, the other functionalities are actually going to run. So let me go ahead and circle this. These functionalities are gonna run after we do this first. So this require is gonna be number 1. Then this is going to be number 2, basically. So think of it as like, hey, this tells Solidity, that this underscore is basically where the other logic of the function will actually go. And of course, we can apply this only owner function, this only owner modifier now to anywhere. We have this exercise where we want to add your own modifier. 1, to check if person is an owner. And 2, to check if contract is paused. And of course, we'll go through that. And if you want to see the exercise, of course, the link is down below in the description for all the exercises in this tutorial. So here's our exercise. It's called modifiers exercise.sol. And we have this token. It's just a pausable token. As you can see, we have an owner of the token. We have pause, meaning if the contract is paused or not. And then we have a balance, which is like how much balance does an owner have. So maybe I might have 10,000 tokens. Someone else might have 5,000 tokens, depending. And of course, initially the owner has how many tokens? 1,000 tokens. That's their balance. And our goal is right here currently, number 1, is to implement the modifier to allow only the owner to call the function. The way you've seen this previously, require only the owner to call the function. So I suggest you maybe pause this video, try it by yourself, and then come back to this video. But in this case, let's try it right together. So just like from the previous example, how do we implement the modifier to allow only the owner? Well, we have to say a require statement, correct? We say require. The condition is what? The message.sender has to equal to owner. That's right. So the owner here. Otherwise, the error code we specify is you are not the owner. So we've done our task number 1, which is to create a modifier like this. Second thing, implement a modifier to check if the contract is not paused. So make sure the contract is not paused. So think about that. We have this paused right here that could be true or false. And want to make sure that the paused is not true, okay? Because we're going to use this modifier later on in the function called transfer, as you can see right here. This is where we will use the modifier. So take a second to think about it and then come back, of course, but let's do it together. Let's create a modifier first, just so we have it in the previous example. We say modifier. Let's go ahead and give it a name. I'm going to say not paused, parentheses, brackets, and we're going to make sure that it's not paused. So I'm going to say require that paused is equal to what? False. If it's not false, meaning if pause is true, then we say the contract is paused. And then of course it tells us there because we are missing the underscore, which is really important right here. This underscore, which tells us, hey, where the rest of the code will go, that will be implemented. And then I'm going to say it underneath. So usually it's underneath underscore semicolon, and that is it. So that's our number 2. Number 3, use the not pause modifier in this function. Should be pretty simple. How? Because, well, you can see how we use the only owner modifier inside this function, for example. Use it in the same way in the transfer function. And so, of course, as you can see, we have these 2 functions called pause and unpause. And so pause allows us to pause the contract. Unpause allows us to unpause the contract. Imagine it's like you're pausing a function and then you're unpausing a function. It's like you're turning on the car, you're turning off the car, basically like that. And of course, only the owner can do that. We cannot let random people be able to pause and unpause the function. Now let's use the not paused inside this transfer function. So I say here public not paused, and that is it. It is that simple. And you can reuse this function, you can reuse this modifier in any other function you want. To give you some context in terms of what's happening here, this is a transferring of the tokens, basically that, let's just say I have 5,000 tokens, you have 5,000 tokens, and I transfer you 5,000 tokens to your wallet. And so here we are requiring, hey, make sure that the user has the more balance than what you're trying to transfer. And then we are changing the balances order. We say balance of message.sender decreases the amount versus who we're transferring to increases the amount. So it's basically that's how the transfer function works. That is actually how the transfer also works in even your normal crypto coins. If you think about Bitcoin, think about Ethereum, think about any other coin, the Dogecoin, the Shiba coin, whatever it might be, they use this type of transfer functions to transfer coins. So this is the same scenario. Let's go ahead and now test this, my friends, because we got this. To test this, of course, don't forget about your handy dandy, my friends, handy dandy testing solution. Make sure you have this big green check mark. That's really important. Let's go ahead and click on this. Use Remix, of course, and then just deploy. And don't forget to remove any other contracts you might have had before. So let's go ahead and deploy our contract. Hit that big deploy button. And there it is, pausable token. First things first, what I want to do is check, okay, is this contract paused or not? Hit that. Looks like it's false, so this contract is not paused. Second thing I want to check is who's the owner of this contract. Hit that. And it says BEDDC4. And who is that? Well, who deployed the contract? And that is this account, the Remix account, EDDC4, right? Same thing as the one that our contract is saying. Next thing, let's check the balance of our wallet, of the owner's wallet. I'm going to copy this account, hit that big copy button right there, paste that in, hit call, and there we go. There's 1,000. Because of course you can see in the constructor, we're setting the balance of the owner to be 1,000. So let's go ahead and now transfer some coins into another account. So we're going to transfer the amount of 100 to who? Well, you can actually hit this little drop down right there. Hit this drop down and actually select a different account. Copy this wallet address and paste in that too. That's it. Now you do have to go back to your other account, the one that you're going to be transferring from. So EDDC4, and then just hit transact. So there you go. We transferred our tokens. There's a confirmation right there. And now let's go ahead and check the balance of our new contract, of the owner. Before, remember, before it was 1,000. So now it should be how much? 900. Let's say 900. There we go. And if we check the previous, the 35CB2, the one we transferred to, I know it's a little bit weird. Copy this one. And now let's check the balance of this person, E5 ECB2, hit call. And that's 100 because that's how we transfer to. So now the question becomes is let's try and pause our contract. To pause our contract, we have this pause button. Let's try actually and pause it right now. If I hit pause, it says what? It says pausable.pause, and the answer it literally gave me is you are not the owner. Interesting. I don't know why. Well, that's because why? The owner is not this 35CP2. We forgot to go back to the EDDC4. There we go. I go back to this one. And now if I hit pause, boom, you can see we got the big green check mark. Check the paused right here. And now this should be true right there. You notice right there. So now that's true. Great. So we know our contract is paused. And before we know we could transfer something, let's try to now transfer again. You still use the same as what we had before, correct? The 100, we're transferring to another wallet address. Let's go ahead and hit that transact. Ooh. Boo. I know. I'm booing as well, okay? Because the contract is paused, and so we cannot transact again. Well, let's try to unpause the contract. Unpause it, and now hit that transact button again, and let's see what happens. Oh, we transferred that. That's right. And so now if we check the balance yet again of our other wallet address, which had before 100, now it should be what? 200. Hit that call. 200. There we go. So there you go. You have just used the modifier, 1, to make sure that the contract is not paused, and 2, to make sure that only the owner can call the pause and unpause functionalities. Very, very useful. Okay, let's now work on changing the max tweet length using a modifier. Now I have these 4 things for you to do right here. And if you want to do this by yourself, you're very much welcome to do. You can just pause this video and then come back. But of course, we're going to be doing them together. And again, our goal is very simple: to change the tweet length using a modifier. So how are we going to do this? Well, the first thing is we need to add a function called change tweet length to change the max tweet length right there. And of course, we can use an input like new tweet length to do this, where we'll just modify this max tweet length to be something different. Second, create a constructor function to set an owner of the contract. And why we need to do that is because only the owner can change the length of the tweet. The CEO of the Twitter, Elon Musk, whatever, whoever it is, right, can change the tweet length. Then we need to modify, create a modifier called only owner to check if the owner is the one who's calling the function. And then finally use the only owner modifier on the change tweet length function. So let's start with this. Let's create a function called change tweet length number 1. I will scroll down at the bottom and I will say here function change tweet length. And there's my function. This is going to be a public function, so always think about visibility. What's the visibility of a function? It's going to be a public function. And are we returning anything? And honestly, when we change something, we're not really returning anything because we're just modifying the state. In terms of our input, what's our input? We know that we need to use an input called new tweet length. So let's add that in. We're going to say here uint16 new tweet length. And the reason why we use uint16 is because this is also uint16. And so let's now modify that tweet length by saying max tweet length is equal to new tweet length. Now at this point you might get an error because cannot assign to a constant variable. We cannot use a constant variable, or we cannot modify a constant variable. That's a problem. So we need to change that constant variable to not be a constant variable, and instead just say uint16 and call it a public variable. And that's it. Now we can see max tweet length is changed to a new tweet length that was defined in this function. So then that is all good. Yes, we got this. Next up, create a constructor function to set the owner of the contract. Because remember, only the owner can technically call this function. So let's create that constructor here. Usually I like to create a constructor underneath all the variables that I have created. For example, this is a mapping, this is a struct. Let's create a constructor underneath. So we say constructor uses parentheses, then we have brackets. So let's just define an owner of this contract. And right now we don't have an owner variable, so we can create that owner variable by saying address public owner and just calling it as it is, which is nothing initially. Now we say here, the owner is who? It's whoever deployed the contract. So the owner is equal to message.sender. Because remember, this constructor gets called when? Exactly when we deploy the contract. And so the owner is the person who deploys the contract. Let's now create a modifier that will use this owner to check for the owner. So we say modifier, give it a name. We say only owner is the name, parentheses, then we'll use brackets. And inside here, let's create a require statement. The condition is what? The person who's calling, so the message.sender needs to be who? Should equal to be the owner. If you're not the owner, then we can say you are not the owner. We do have an error because we have to specify the underscore. The underscore which tells Solidity, hey, this is where the rest of the code will run. First, you will run this, and then you will run the rest of the code in the function that we implemented, this only owner functionality. And then finally, that's all good. So we can mark that off. And then let's go ahead and use only owner on the change tweet length function. Let's go ahead and say only owner can call this function. And at this point, I think we're all good and dandy. Let's go ahead and go to our deployment section right there to test it. Again, make sure you remove any previous contracts you might have had before, and make sure this is called the Twitter contract, whatever it's called, and then just hit deploy. Great. So you should get the green check mark. At the bottom, make sure you hit this drop down arrow. There we go. Here are our functionalities. So to check, here's our max tweet length right now. It is 280. Let's say you want to change it to be like 400. And of course, if you want to change it to be 400, we have to be the owner. So let's check who is the current owner. There we go. And it is, as you notice, DDC4, which is the person who deployed it right there. Because we are the owner, we can technically change the tweet length. So let's just say I want to change the tweet length to be, I don't know, 300. There we go. Now it's 300. And all I have to do is just simply hit transact. And as you can see, it went through. And now our max tweet length is going to be 300. Now, let's try to change the tweet length, and let's, with a different account, that account that's not the owner. So I will do a different account, say CB2, like right here. So I will select that account. And now let's try to do new tweet length and call it to be, let's just say 400. Hit that big transact button. Oh, error. Nope. Nope. Nope.
Boo!
Yeah, that's right. Bull indeed. Okay, my friends. So he says, you are not the owner. It's exactly what we are looking for. And that is it. You have just added a change tweet length functionality to your contract. You have used a modifier right there. You have created a constructor to create the owner. This is looking pretty good. It's starting to look really, really good. So great job with that, my friends. Let's go ahead and party. Anyways, okay, that's it. Ooh, it is so exciting. We are so close to getting things finished. That tea is so good. But right now what we're going to do is we need to add the likes to Twitter, right? Everybody likes to be liked. You like those likes. I know you do. So let's give people the ability to add a like to the tweet itself as well. And so I've actually created the exercise for you right here. And if you want to check it out by yourself, again, all the exercises are down below in the description for you to go ahead and check it out. And for you, all you got to do is 4 steps. I know it's quite a lot, but don't worry. Of course, we will do everything together as well. It's just I always recommend, hey, try to do this by yourself at the same time. So here it is. We want to add an ID to tweet struct to make every tweet unique. That's point 1. Reason being is because later on when we like the tweet, we have to be able to reference, hey, what tweet are we liking? And so we're going to use IDs as a way to reference that. Point 2, set the ID to be the tweet length, okay? So in the struct, when you create the ID, when you create the tweet, we're going to set the ID to be whatever the tweet length is so far inside this mapping pretty much. Again, you'll see how that works like. Then we're gonna 3, add a function to like the tweet. So pretty simplistic. Add a function to unlike the tweet. Again, also pretty important. And then finally, make sure to mark both functions external. There we go. So again, if you want to do this by yourself, just go ahead and stop this. But let's do it together. So first things first is add an ID to a tweet struct to make every tweet unique. Pretty simple. First part we need to do is always add it to the struct itself. So I'm gonna say here, ID. I'm going to say here uint 256 ID. That's going to be the ID of every single tweet. It's like a unique identifier. It's kind of like your name, right? You're a person, you've got your name, that's your name. But actually even more so unique is probably your social security number if you're in USA, for example, okay? Now when we create the tweet, things are going to be different because of course now we need to add the ID as well. So we say ID is what? So imagine, for example, we have 3 tweets so far right here, okay? And we're going to create the 4th tweet, basically the 4th box, and that one is going to have the ID of 4. So we need to get the current ID length. So what we're going to do is we're going to say here tweets for message.sender, right? Because that's how we get all the tweets, .length. And so what's going to happen is that the length of this, for example, is going to be 3. Let's just say 3. Then the 4th one is going to be this one. Okay, that's how you want to think about it. That's going to be, so that's going to be the ID of our next tweet. Step 3, add a function to like the tweet. So I'm going to do this underneath the create tweet function. Underneath that, let's go ahead and create a function here. We say function like tweet, parentheses, like as always, brackets, and now let's go ahead and modify this. What kind of a function is it? Always think about what is the visibility. Is it public? Is it external? Is it internal? In our case, it is going to be external. We can also say public, but we know this like tweet function is not going to be used anywhere internally right here. So we're just going to mark this to be external. Next, think about what parameters are we going to add to this function. Well, think about this. There should be 2 parameters, ID and author. Why? Because if I'm liking a tweet, you have to know, 1, in order to get to that tweet, right, the tweet where it's stored, you have to know the address, and then you need to know the ID of where that tweet is stored as well. So that's really important. So when we like the tweet, we're going to say here, the input is going to be the address, the author of the tweet, okay? And then, of course, the uint 256 ID of the tweet. And now all we do is we reference that specific tweet. So we say here tweet. So we say here tweets were at the author, That's right, at the author, and then the ID that was given to us, and now we get the likes. So we say dot likes plus plus, and what plus plus means is basically incrementing the likes by 1. It is the exact thing as saying likes is equal to likes plus 1. It's the exact same thing. So let's always think about likes or plus plus as just simply an incrementer. We are liking the tweet, all great, but what if the tweet does not exist? What if you're trying like to break the contract for some shape or form by putting in the wrong author or putting in the wrong tweet ID? So we have to account for that too by creating a require statement. And so there's a few ways to go about this. Basically, the best way to do this is we say require, and we want to try to access the tweet with that author. So I'm going to say here, tweets of the author of that ID. Now, but it's not just this. I cannot just say here, okay, otherwise the tweet does not exist. We cannot just do that because now you're trying to compare this to an actual structure. So we have to say dot ID. So some kind of ID within that needs to be equal to the ID that we're trying to get right here. That's basically the goal here. Hey, is this the correct ID? If it's correct ID, okay, all good. Then we can like the tweet, no problem. Otherwise, then it's just not the correct ID. Okay, so we're good with that. Hey. All right, moving forward here, let's go ahead and add the third one, which is going to be add a function to unlike the tweet. Also pretty important. So let's do that right now. Say function here underneath the like tweet function. We say function unlike tweet. And in the same situation, we have to pass in the author, or who's the author of that tweet initially, and the ID. So I'm going to say here, address author, uint 256 ID. And what kind of function is it? The external, public, it can be public, but it can also be what? But it can also be external. Remember, internal means you're going to be using this inside the contract. You will reference the code inside the contract. External means you will never reference the code inside the contract. Instead, it's going to be used for external purposes. Now, to unlike the tweet, we're going to say here, again, reference it. So we say tweets, yes, author, beautiful, ID, like so, ID, and then dot likes. And now we say minus to decrement the count. Okay, same problem here. You cannot decrement the count if the tweet does not exist. And we also want to make sure that we don't go into negative, likes. That'd be pretty horrible. Imagine seeing your Twitter and you're saying you have negative likes. That'd be pretty horrible. Oh, you'll be crying. So anyways, so we say here again, let's go ahead and do a require statement on this one as well. And we say here tweets author at the ID, correct? Dot ID should equal to the ID that's provided by us. Otherwise, we say tweet does not exist. But that's not it, because now we need to check, hey, are there more than 0 likes? So we say here require tweets, again, at the author, at the ID, the likes needs to be greater than what? 0. That's right. If it's 0, then we just say there are no likes. Tweet has no likes. And that's it. So we say that likes needs to be greater than 0. Otherwise, the undeclared identifier, the author. Oh, sorry, I misspelled author right here. So author. Tweet has no likes. And of course, if it does have likes, meaning the likes are greater than 0, then we can unlike. And that is. And of course, we did make both functions external. So at this point, we are all good. Shall we test this? Yes, let's go. Let's go to our handy dandy testing option on the left side. Click on that option. We're using Remix VM as always. Scroll down. Make sure you hit the big deploy button. There we go. And you should see our Twitter contract right here. Again, make sure you remove any other previous contracts so you do not get confused. Let's hit that big drop down arrow. Make sure you hit this drop down arrow. And let's try to just create a tweet for now. So let's just create a tweet because, of course, you cannot like something unless you create a tweet. So I'm going to say, hey, yo, what's up? What's up? That's not how you spell that, but it's okay. Hit transact. Boom, we got the big check mark. Hey. Now, next up, let's try to like the tweet. We can't technically like our own tweet. That's fine. Who is the author of this tweet? Well, the author is basically still me, so I can just go ahead and put myself as the author. The ID of the tweet we're gonna like is ID of 0 because we know that's gonna be the first tweet. So I hit transact, and now we have liked our tweet. Now let's go and see our tweets to see if that like is there. So I'm gonna say here, get tweet ID of what? Get tweet ID of 0, hit that call button, and you will notice here, yo, what's up? 1684, and then the last number right there, you might not be able to see it, but it's that 1 right there. That 1 is how many likes the tweet has. That's right. So I can do the same thing. Let's just say someone else comes in and likes my tweet as well. Let's go ahead and modify my account to be someone else. Let's just say it's 35CB2 on the top side. And let's go and like the tweet as well. So I'm going to say hit transact. And let's go and try to get the tweet. If we call right now at 0 position, it's going to get you what? An error, because why? It doesn't really exist. That tweet does not exist. So we have to go back to our initial user, the C4, and then get the tweet at position 0, hit that call, and now we have officially 2 likes right here. Now let's go ahead and try to unlike the tweet. So I'm gonna say here, unlike tweet. Again, who is the owner of that tweet? It's me, so I'm gonna pass that in. And you might be asking the question, hey Naz, how does everybody know who's the owner of that tweet? How are we supposed to know that? Well, we're gonna know that because imagine we're using this contract and then we're tying this together with an app. Usually the app is gonna get all the tweets initially, and then we're going to get all the tweets data. And that tweets data is going to have the author. And so later on, when you like the tweet, that author data is already present to you. You already will have that tweet data. You will have the author. And so when you try to like the tweet, you're going to pass that data into the contract. Okay, moving forward here, let's try to unlike the tweet. We're going to say here ID of 0, transact. Okay, seems to be all good. Let's try to get the tweet. And you can see it went back down to 1 right there. And then, of course, as always, we can always get all tweets as always. So we can just say get all tweets. Here is the owner. The owner is going to be me. Hit call. And here's a list of tweets. And, of course, here's my tweet with the ID of 1. That is it. You crushed it. Good job. Now, I know you're probably like, Naz, okay, we've got this cool contract, but I want to see this on the actual Ethereum network. So let's deploy our Twitter smart contract to the Ethereum test network. Now, of course, we're not going to use the actual Ethereum network because that's going to cost a lot of money to deploy. Instead, we're going to use the Sepolia network to deploy. There are a few steps you need to do in order to make this work. The first step, number 1, you have to have a MetaMask account. If you do not have a MetaMask account, there's a ton of YouTube videos out there how to install it. But you can simply go to MetaMask, for example, MetaMask, and click on the MetaMask right here. Just download for Chrome and then go through the installation process. And that's it. And then you'll be good. Those of you who do have MetaMask account, we're gonna use a test network called Sepolia. The first thing we want to do is actually go to Sepolia Faucet. So type in Sepolia Faucet right here. There it is, Sepolia Faucet. Click on that one, and there is our Sepolia Faucet. Okay, fast and reliable, 0.5 Sepolia ETH per day. Now, when you go to your MetaMask account, it's very important that you get the correct address, okay? Here's your accounts. Of course, on the top right, you got your accounts. Select the account you want to get the money in. Make sure we want to use the Sepolia test network. So you want to click on this kind of drop down section, click on this one, and then you should see Sepolia test network right here. If you do not see it, you might have to click on your icon, go to settings, go to advanced, scroll down, and you would need to say show test networks. Make sure this portion is on. Very important. And then you should see Sepolia test network after that. Right now I have 0.5 ETH. Okay, you probably have 0. What you want to do is you want to copy your contract address right here. So I'm going to have hit copy and then paste in your contract address right here. It might ask you to log in or to sign up with Alchemy, but that's okay. You just go ahead and do that. And then what you want to do is make sure you say I'm not a robot, because I am not. Well, sometimes. And then hit send me ETH. There you go. Sepolia Faucet will be sent to you. And no, my friend, you're not about to get rich. This is not real money. This is literally just for you to test your contract with. Let's go ahead and actually now check it out. So you can click on this X. And then if you look at your MetaMask account, you should technically now see more Sepolia ETH. You can see right now I have 1.0. Once you have that, let's go back to our remix and we want to deploy our Twitter contract to Sepolia test network. Again, let's go back to our handy dandy deployment section on the left right there. And right here, instead of hitting remix VM, you're gonna click on this and then you should see injected provider MetaMask. Select this one. It's gonna ask you to connect your account. Make sure you select the account that you have Sepolia ETH in. I will hit next. I will hit connect and there we go. That is pretty much it. I have, and it should say right here, Sepolia, some numbers network. At this point, all you have to do, and you're pretty much done, is you just have to just simply hit and deploy. Hit the deploy button, and very important, make sure you have, this should be 0. Make sure you also delete any of your other contracts right there before, so it's all clean and clear. But at this point, let's go ahead and hit confirm. You can see this is how much it's going to cost you. Hit that confirm button. On the bottom, you should see view on Etherscan. It's a bit hard to see, but it's right there. View on Etherscan. Click on that one, and you should see your contract on Sepolia network. And there's your contract right here, 0xDC 203. Hit that one and there's your contract creation, and it is as simple as that. Now we're not done yet because we want to test some things now with it. Let's go back to remix. If you scroll down the left section, you will see your Twitter contract right there, okay, the one you deployed to Sepolia. Hit that drop down arrow and let's try and create a tweet. I will go ahead and put in a string. Yo, this is my first tweet. Hit that big transact button. It's gonna ask you, of course, for your MetaMask account, because it's very important. Whenever you are adding something to the blockchain, it's gonna cost you gas fees. Now, right now, of course, you can see it's pretty small, so we don't have to worry too much about it. And so hit confirm to do that. Hit that view on Etherscan at the bottom right there. Boom. It's gonna take some time. Sometimes it takes a second or two. There we go. Looks like it went through. So looks like we have 3 block confirmations. Again, if you click on this button, you click on your contract, you will see the create tweet function right there. So you have created a tweet and now you can interact with it as well. You can actually get the tweet. So let's go back to remix. And if you want to see all tweets, underneath the get tweet section, just put in the ID of 0, hit that big call, and then there's your tweet. Yo, this is my first tweet. As you can see, yo, this is my first tweet. There is our tweet. And you, my friend, have just deployed your smart contract to the Sepolia test network. Now that is pretty cool. Let's talk about events, or as I like to call them, notifications, because literally what they do for you is they notify you. That's right. And they're one of the most important things on the blockchain. Yeah, that's a lot of notifications. Hopefully you don't get that. But it's like you're notifying someone of what happened on the blockchain side. Those are called events. As I said, they are notifications for the blockchain. Pretty much what you usually have is, imagine you have a function in Solidity. You got your normal fancy logic, maybe you're maintaining an NFT, and maybe you're doing something else. And then what you do is you fire off an event. And you're basically saying, hey, I completed this function, and here's the data that I completed with. And again, you control that. You control the event that the blockchain sees. And that gets saved on the blockchain side. Here's kind of how it works in general. Imagine you have an app, okay? Maybe you're building a Facebook app, or maybe you're building a Twitter app, whatever it might be. You've got your function to create the tweet, okay? You create the tweet, all great. You call this function in the smart contract. And then what happens is, in the smart contract, you're creating an event and you're storing that in the event. So you're saying, hey, my event is I have created a tweet, okay? So let's just go ahead and put this on here. Create tweet. Then you're making an event. You're saying, I have created the tweet. Then what happens is that your app is listening right here, is listening on any potential new events. And whenever new events happen right here, it sends that update back to your app. So whenever you create an event that says, I have created my tweet actually goes back to, let me see here, my tweet goes fully back to the app. And now your UI, your user interface, can update that and can see it and be like, oh, okay, looks like you created a new tweet. Let me go ahead and show that on the app side. And so it's very important because, one, it's important for Web 2, and 2, it's just important for documenting what's going on the blockchain side. As an example, which is really cool, I have the Azuki contract. if you look at the contract, there's your code right there. Now in this contract, if you go down to the file 4, which is the base Solidity ERC71 smart contract, you will notice the emit function, the emit transfer event. And it emits the event with some data like from who to who, and the token ID. At the same time, at the top, if you look at this events button right there, let me go. If you click on this events section, if you scroll down, and actually there's a ton of events as you notice. There's an approval for event, there is a transfer event, there's an approval event, right? And they all have data. For example, this is the data that's provided to us from the event, like the address, the index topic ID, and so forth and so forth. And here's even, you can see what type of data the event has and how long ago the event was created. So you're basically just logging what's going on in the contract. Again, got more transfer, more approvals. And so they're very useful because later on, I can actually search through events. So here's how it kind of looks like in terms of events. The first thing you got to do is you always have to create the event. So in this example here, we have our contract called event example. And what we're doing is we're defining the event. Event, you're given an event name, could be any name, and then you're specifying what kind of data will you be storing in that event. So this could be like an ID, could be a string. You might see this, for example, indexed, and this index is very important because you're saying, hey, cache the index of this data. And this just simply allows you to filter by this data point a lot faster. So you've created the event, boom, all good. The next thing is to emit the event. So when something happens, let's just say we have some function, now you want to emit the event and save the event with the actual data. So you might be saying, hey, emit, again, you're calling the same event name right here, providing it some kind of a data, and then that will be saved on the blockchain side. And that is pretty much it, my friends. That's right. Moving forward here, of course, we got ourselves an exercise. Again, all the exercises are down below in the description if you want to check this out. In this case, it's a pretty simple one. You want to add your own event when user registers. Again, this is just a random example here. We have a user struct. We have a mapping between an address to a user, and we're registering a user, kind of like a sign-up contract. So there's our contract right here. And I even give you number one and number two in terms of what you need to do. We'll just simply we have a mapping. We're registering a user with some username and the user age. So pretty simple on that side. So let's go ahead. Number one is let's go ahead and create an event, add an event called new user registered with two arguments, the user as an address and the username as string type. So let's do that. So we'll say here event. Okay, let's give it a name called new user registered, and let's go ahead and put in the data. So the first data is going to be a user, which is an address type. So I'm going to say here address user, comma, and then the string type as a username. So we say here string username. So pretty simple on that side. Now let's think about what kind of data might we want to index, because sometimes you want to be able to filter by data, and most of the time you might be filtering by the address. So I'm going to say here indexed to say this is an indexed value. Again, index just means, hey, I'm storing this data and so that we can access that data really fast. It's kind of like indexing on the database side, if you know what that means. So you've got that. Boom, there we go, in the books right there. Next thing, we need to emit the event. So fire off this function called register user. We provide the username. We provide the age. We store that data, okay, in the new user. Now we want to go ahead and emit this event when this is all done. So let's go ahead and do an emit new user register. So I'm going to copy this one, paste it into the event. And of course, make sure you add now the correct data. So the first data point that we need to add is going to be the user address. So we say here message.sender is the user address, of course. And the second thing is the username. So again, we're going to pass in the underscore username as a way to emit that data. Everything seems to be all good. Now let's go ahead and deploy to our test network. Of course, let's go ahead and get our fancy handy dandy deploy and run transactions button. And at the top, you might see a few different things. Now, the one you want to select, of course, is going to be the injected provided MetaMask, because we are deploying this to the main Ethereum test network. Make sure, of course, you have some Sepolia ETH. If you do not have Sepolia ETH, you can use the Sepolia faucet to get it, and make sure you are on the Sepolia test network right here. At the same time, make sure you cancel out all your other contracts, and let's go ahead and just hit deploy. deploy. It's going to ask you for your MetaMask confirmation. Hit that confirm button. Beautiful. You can view on Etherscan to see the transaction happening. Boom. All right. You've got yourself this. So here's our register user function. Here's our users. And now we can go ahead and actually use this. So let's do this. For the username, let's go ahead and input a username. I'm going to say username of Naz Dumansky. And then the age is going to be 27 because that's how old I am. Transact. There we go. It's going to ask you for your MetaMask confirmation. And inside that, you notice here, you'll actually see what function are you doing, and then just hit the confirm button. Okay, let's go ahead and hit the view on Etherscan to view our transaction on Etherscan. There it is. Give it some time for it to actually confirm. There we go. There it is. There's our contract. And so here's the contract. And you might notice here, you don't really see much. Like, for example, the method is some weird method ID. Same thing goes for this. And if you go to events right here, let me go and zoom in for you. In events right here, you'll notice that there is an event that was done 39 seconds ago. However, you don't see the name, and it's like a bunch of gibberish that you don't really understand. And that is because we need to verify and publish our contract. That's right. You need to verify with Etherscan that this is your contract. So what we're going to do is we are going to verify and publish. Let's go ahead and do this. So I will click on this verify and publish section. Now, you might have already been verified and published because this contract, if it's somewhere in the network, it will actually verify the contract automatically for you, which could be the case. However, if it doesn't say that, then you have to do it. So let's do it together here. It says, please select compiler type. I'm going to select the compiler type. It's going to be a single file. And then it says, please select open source license type. It's going to be MIT. Then it says, please select the compiler version. That's very important. Go to your remix. Go to the compiler section right here. Click on that one. And then it says right there 0.8.18. And that is the exact one that we need to select right here. 0.8.18. Now hit the continue button. And then it says enter the Solidity contract below. Pretty simple. Now all you do is you do Command A, Command C to copy the whole contract code. And then Command V to paste it in. And then at this point, all you do, don't worry about this ABI. Just hit that I'm not a robot, and then just do verify and publish. And if you did everything correctly, if you copied the contract exactly as it should be, you should see that successfully generate bytecode and ABI for your contract address. And now your contract is fully verified. That is pretty cool. And now if you go back to your contract address right here, this one, and you'll notice actually that the code appears in the Etherscan. How cool is that? There's your code right there. There's your registered user, there's everything. And now, an even cooler part, check this out because I'm so excited about this. If you go to events, there's your event, new user registered. The exact event that you set up in your contract code. It says register users right there, new user registered. And then of course, initially is going to be the data for the address user and the username. Now again, the data here is also not still fairly unclean because this is all hex data, but this hex data can be converted to actual data when you get it into your program. And that's it. This is how it all works out. Pretty cool, huh? And there's your events, my friends. Hopefully you enjoyed that. That's it. Let's go ahead and create an event in our Twitter smart contract so that we can notify everybody who's using the smart contract when you created the tweet and when you liked the tweet. Let's see what we need to do to make this work. As always, the exercise is down below in the description for you to go ahead and check it out. And you're all welcome. Yes, you're welcome to do this by yourself completely. But of course, we're going to do this together at the same time. 4 things we need to do. 1, create the event. 2, emit the event. 3, create the event. 4, emit the event. That's it. Done, done, so boom, done, done. Okay, not done yet, but anyways. So first things first is create the event for creating the tweet called tweet created. Create the event. Let's just define the event first. If you scroll down, I actually have shown you where to define the events. We're going to create our first event. I'm going to say here event tweet created. And of course, we need to specify the data inside this event. And it's really important because it says here, use parameters like ID, the ID of the tweet, the author of the tweet, the content of the tweet, and the timestamp of the tweet. So let's go ahead and add the first things first is going to be the ID. But of course, you have to define what is the type. So I'm going to say uint 256 ID, comma. Then we're going to get the author. So we say address, author. Author, of course, is going to be the MetaMask wallet. And then, of course, we've got the content. So that's going to be a string content. And then, of course, we've got the timestamp. And if you remember, the timestamp is always what? A number, as you can see right here. So we will say uint 256 timestamp. And don't forget the semicolon, otherwise you are screwed. So there it is. Okay, moving forward here. So this is done. Awesome. Next one is going to be emit the event in the create tweet function below. So of course we define the event. Now we need to actually emit it when we create the tweet. So in the create tweet function, we create the tweet, we save it in a tweets array or in a mapping, of course, and now let's emit this event. So we say emit event name, which is going to be tweet created. So the first thing is going to be the ID. It's coming from here, this new tweet ID. So we say here new tweet ID. Second is going to be what? The author. So we say new tweet.author. New tweet.author. And then we've got the content. So we say new tweet.content. And then finally, the last thing is going to be new tweet, the timestamp, right? So new tweet.timestamp. There we go. Don't forget that semicolon. And there is our emit event. So everything should be good at this point. Mark this as completed. Hey. I love that sound. I don't know why. Then, of course, third one is going to be create the event for liking the tweet. So we've got the event for creating the tweet, but now we want to create one for liking the tweet. Underneath the tweet created event, we will define a new event and call this one to be tweet liked. Of course, what data do we need to use for this event? It says use parameters like liker, so who liked the tweet author, the tweet ID, and the new like count. So we can keep track of the new like count that is part of that tweet. So we'll say the author's whose address, liker. And then we've got the author, so say address, tweet, author. Then we need to create the ID. So we say uint 256 tweet ID. Then, of course, we've got the new like count. So uint 256 new like count. So there we go. So there is our event that has been defined. Mark this as completed, my friends. There we go. And finally, the last thing we need to do is we've defined the event. Now let's go ahead and emit the event in the like tweet function below. So here's our like tweet function. At this point, all we need to do is just simply emit the event. So we say here emit tweet liked. So of course we need to provide the data. So tweet liked, the author, the person who liked it is going to be the message.sender. Then who's the author of the tweet? Well, that's simply going to be author. We get that data directly from the actual parameter. And then of course we need to get the tweet ID. So that's this ID right here, this tweet ID. So we say ID, comma, and of course the like. So what is the new like that we have as part of tweets? So we say here tweets. Again, we just get this by using this specific parameter. This right now increases the like, but by calling this, we actually can get the like. So we say tweets at position of author, at position of ID dot likes. And that is our new event emitted for a tweet liked. So that's it. You have made that happen. Yeah! Congratulations. But of course, we're not kind of done yet because we have one last thing to do, which is not on this exercise, but it is to unlike the tweet. So I would suggest to you can try this by yourself because we have the unlike tweet function. I would suggest you do this by yourself as well. But of course, we're going to do this together. So to unlike the tweet, let's go ahead and create another event called tweet unliked. So in this one, I'm going to say here, event tweet unliked. And of course, who's the unliker? It's going to be the address unliker. I know it's a weird name. And then the address of the tweet author, just how we have above. And then of course, then I'm going to specify the tweet ID. So uint 256 tweet ID. And the last thing is going to be the new like count. So we say here uint 256 new like count. All right, so we've got this new event called tweet unliked. Let's now use this event in our unliked tweet function. So there's our function, unlike tweet. I can actually just copy pretty much all of this, emit tweet liked, and put that into here, except this one, I'm gonna say emit tweet unliked. There we go. And then again, it's still who the author is, message.sender, the author, the ID, and of course the updated likes. So nothing in terms of data that changes. The only thing that changes is pretty much is the event that gets emitted. And that is it. And of course, at this point, all we gotta do is just simply test this. So let's go ahead and test this. Go back to our handy dandy deployment solution. Click on that solution, of course. Let's go ahead and use MetaMask to deploy to Sepolia. Our favorite handy dandy Sepolia. And of course, don't forget to go to Remix right there. Hit inject to provide a MetaMask. There we go. Select that. Let's just go ahead and hit deploy. Hit confirm and let it deploy. Of course, let's view on that Etherscan. Looks like it's loading. Beautiful. Yes. So there's a deploy contract right there at the bottom. And of course, now we have the like tweet, the create tweet, and all that. So let's go ahead and just try to create a tweet and see if that creates an event in the blockchain space. So I'm going to say here, create the tweet. I'm going to say, this is my first tweet. I'm not a sinker, by the way. Hit that transact button. And of course, don't forget to hit that confirm button. Look, when you make videos, you gotta have fun, okay? Because you're talking to a camera. So I gotta make this fun for me, as fun as I'm not sure if it's fun for you to watch it, but you know, I gotta make it fun for me too. Anyways, let's see. Hopefully it's done. There we go. That's done. So let's look at our contract. There is our create tweet contract, as you notice. And if you look at even our events, you will notice there's an event called tweet created. There it is, right? Tweet created. And we have all the data like the ID, the address author, the content, the timestamp, and so much more. And of course, you might not necessarily understand this data because this is all hex data. When you actually capture the data later on, when you get that on the Web2 side, you will be able to convert the data to much more readable data. It just works. Woohoo! Moving forward, we are now implementing your smart contract into an actual application that I like to call a Twitter DAPP. That's right. Here it is, my friends, okay? So very simple, basically, in terms of a Twitter DAPP. But basically what happens is that imagine you connect your wallet, your MetaMask wallet, and boom, you're connected to your wallet and you see all your tweets that you have made. You can actually make your own tweets. For example, this is today is a good day, for example. That's what people like to do on Twitter, right? So today's a good day. And we make that tweet. When you make that tweet, of course, we got this beautiful loading bar right there. It's asking you for confirmation because, of course, you are creating the tweet. So we need to go ahead and hit that confirm button. It does take a while because blockchain is not the fastest. So it does take a while for us to load all this.
2,000 years later.
But as you can see, it says today is a good day. And so there we go. There it is. Today is a good day. And that's my tweet. Now, I can also like the tweet. So for example, let's just say I hit the like button. So I hit like from that transaction. So I hit that confirm button right there. Again, it takes some time. Okay. You got to be patient with it. Blockchain is not the fastest, but it's cool. It's cool. So anyways, it's still loading.
2,000 years later.
You know, hey, let's go. Beautiful. There you go. So there we go. We got that one like right there. So that's going to be our goal, is to finish this. Now, in terms of an exercise, most of this is done for you in terms of the front end application. Your goal is to build the Solidity Smart Contract portion of it, okay? Here's our exercise. There it is, okay? I have created this exercise for you using Code Sandbox. So in order to get this exercise, of course, link down below in description if you want to do this by yourself completely. But of course, we are going to do this together as well. Oh, there it is. So I have labeled this like 1, 2, 3. I think there's like 7 steps altogether that you have to do. So you can read through those yourself if you want to do this by yourself completely and try to do this as well. When you're done and you're finished with everything, you should have a fully working application just like this. Other than that, let's get this party started, my friends, because I am excited. Let's do it. Of course, if you want to pause and go ahead, if you want to pause and do this by yourself, you're welcome to do that. But if not, then let's get to work. First things first, we need to do, let's just go through a little bit of our contract. Let's go through a little bit of our code and see what are we dealing with here, because of course there's a lot of things I want you to consider here. We have a few files here. We have the API.json, we have the index.js, and we have the styles.css and the index.html. So in the index.html side, you'll notice here that we have a few things, including things like the connect wallet div. You'll notice things like the form where you actually submit your tweet right there. And of course, we have the tweets container where all your tweets are saved. Then we've got our scripts. So all your scripts for connecting wallet and font awesome, those are scripts are in there. And of course, we have the styles of CSS connected inside here. In the style of CSS, fairly kind of explanatory. I'm not going to go deep into this. This is not a CSS tutorial, but this is what makes this look pretty. That's all I can say to you right there. Then of course, we got our index.js. This is where all the magic of JavaScript happens that ties together with the smart contract. And so this is the really important part as well. And this is where you will be working mostly, okay? And then we've got the API.json. This is very important as well, because API.json is, think of it as a instructions manual to your smart contract. If you have ever probably bought an IKEA desk, for example, and you're reading the instructions manual, hopefully, some of you probably not, you probably will go through the instructions manual and, to put things together to get the full result of the IKEA desk or the IKEA shelf, whatever it is that you bought. I want you to think of this as an instructions manual. You are instructed. This is an instruction on how to use your smart contract. For example, this specifies all the variables in your smart contracts. For example, like the tweet length. And then you have things like the create tweet function. Then you have things like the like tweet function. So this tells our front end, our web 2, here is the functions you can call in the smart contract. So that's what the ABI is for. The term for it is called application binary interface. Yes, I know. Very fancy. So there it is. And of course, we use all that inside here. We do import contract API from API.json because this is what we need to use in order to actually get your smart contract. First things first, let's just read through what we need to do here. Step 1, we need to request a wallet connection from MetaMask. Okay, this is a connect wallet function right there. And this is where when I hit this connect wallet button, it executes this connect wallet function, and somehow it needs to connect to my MetaMask wallet. You might be asking, Hanas, how does this work? Well, it's not that crazy, actually. If we read this, I have this article for you right there. If you read through this, you will actually find how to connect your wallet. There's this thing called get account function. And you'll notice here that this get account function does a very simple thing. It does accounts is equal to await window.ethereum request method ETH request accounts. And this is given to us by this Ethereum object automatically, okay? So what I'm going to do actually is I'm going to copy this, and that's what I'm going to use. Take this to our DAPP. There we go. Command V, and there's our accounts. So if you want an explanation of how this kind of fully works a little bit, this win.ethereum.accounts, Ethereum is actually an object that's given to us by MetaMask. So MetaMask installs this Ethereum object that has all these things like request method and so many other things that you will use with MetaMask. If I go to the console here, you notice if I do Ethereum, there we go. If I hit enter, there is our Ethereum object that gets inputted by MetaMask. So MetaMask is like, here's all the functionalities you can use to use me, pretty much. That's how you want to think about this. We've got our window Ethereum, and what we're doing is we're requesting ETH request accounts function. And then if you don't request an account, then we just say, hey, please connect MetaMask. That's all we're saying here, okay? When you get that, you get this account variable. And how does this look like? Well, let's do console.log, and let's do console.log account just to see what do we get inside here. If I hit connect wallet, okay, there we go. I hit next, hit connect. There we go. Awesome. And let's see now. Ooh, look at that. So it says, there's our account. And we get this array of data where the first index is actually your what? Your MetaMask account address. There's your account address, right? 357. So that gives your MetaMask account address. And that's really, really important because you need to use that in order to execute any functionality on the smart contract side. And so what we're doing here is we're using this account. We're getting the first account and we're setting that to be connected. So this set connected function is very important. It does a lot of stuff here in the bottom. Here is our second function. You'll notice here, it just it takes your address, it sets the address to be connected, and then it kind of displays your form. That's the most important thing that it does for you. So let me go and refresh here one more time. Refresh, hit the connect wallet button, and then of course you can see it displays your form and displays your connected. Who are you connected to? You might be thinking, oh, Naz, I'm done. Great, awesome. No, okay, no. Because we're not done yet, because we have a lot more things to do. So here's our smart contract from the previous video. And so of course, all we need to do now is just simply launch it on the Sepolia test network. Of course, make sure you have Sepolia ETH. That's really important. And let's go and do that. Don't forget our big deployment section right here. Click in the deployment section. And of course, make sure on the top when it says environment, make sure you hit injected provider. It's very important. That will usually pop up your MetaMask account to connect to it. And then we're all set. At this point, just go ahead and hit deploy right there. And then let's go ahead and deploy our contract. Hit confirm. View an Etherscan to view that deployment. Hey, there we go. There is our smart contract. And what we need to do is just simply copy this address, right? Hit that big copy button right there. And then go back to your Twitter DApp and then paste this in. Now, very important, I specify this is very important. If you deploy your smart contract not using MetaMask, you are screwed. You're deploying to not Sepolia. You're deploying to a local blockchain that like Shanghai, Merge, London, for example, okay? So make sure, and I repeat this many times because a lot of people screw this part up, make sure to select injected provider. In that case, let's go ahead. We added that smart contract address inside there. This looks to be all good, and that's all done. That's all done. So number 2 is done. Yes. Hey. Okay. Number 3, connect to the contract using Web3. So how do we make this work? So we got this connect to the contract using Web3. So Web3 is actually a library that we use to connect to the smart contract. Imagine this is your app. Imagine this is your smart contract. So this is the app smart contract. And imagine what happens is that Web3.js is the middle layer between all of those things. So what it does is that you call Web3.js. Web3.js talks to your smart contract through MetaMask, of course. And then that's how you get back information through that. So that's how that works out. How do we now connect to the contract? That's the question. We initialized our Web3 inside here using window.ethereum. Again, that's provided to us by MetaMask. I give you a hint right here, a link that tells you exactly how to connect to your contract. There it is right there. So it takes you to this new contract function. So this is pretty interesting actually. You'll notice here, we have this new web3.eth.contract. The input is JSON interface, and then some other things and other options you can provide. But the most important one is going to be the JSON interface for the contract to instantiate. Okay, then of course then the second input is going to be the address of the smart contract to call. And then we have other options like from, guest price, gas, and so forth that we don't really need. And you even have an example right here showing you how to connect to the smart contract. So pretty cool. So let's do it this way as well. Let's go ahead and copy this new Web3 ETH contract. Copy that. And I even give you a hint here for let contract. So I say let contract is equal to new Web3 ETH contract. And then you'll notice there's 2 things we need to provide. One of them being what? The JSON interface. And we talked about this before. The JSON interface is what? That is your ABI, your instructions manual to the contract. So where do we get that from? Well, we have that right here, contract ABI. So we say here, contract ABI. Then the second parameter is usually going to be what? The address. So the address of your smart contract, which we have that as well right there, contract address. So we say here, contract address, and we are done. That's it. So we've created our contract. Let contract is equal to new web3.eth.contract, and that is it. Now, of course, at this point, if I refresh this, for example, right? I'm going to refresh this. If I connect the wallet, yes, we have the tweet. But at this point, you still cannot tweet. If I say, yo, for example, and I hit tweet, it's not going to really do anything, as you notice here, right? Because, of course, we don't have the functionality. Third one is done. Let's go. Good job. Let's look for our 4th thing we need to do to finish our functionality. And here it is. So this is going to be the create tweet functionality. So we say here, on the 4th time, what we need to do is we need to call the contract create tweet method in order to create the actual tweet. And then I even give you a hint on where to find the documentation for that and how you can call the function in the smart contract. Don't forget to use the await feature to wait for the function to finish. Now again, if you look at our contract code, you'll notice we have the create tweet function. We need to now call that function to create the actual tweet. So let's go to this URL, copy this one, paste that one in. And so it should take you to another one, which is, this is called methods.myMethod.send. What you do here is that you use your contract that you have created. You say .methods, and then you call the method of the contract. So that could be any method, a main function, a create tweet function, whatever it might be. And then, of course, you provide the parameters of the function, and then you say .send. And so if we scroll through down below, we will see an example here. My contract.methods.myMethod, some kind of an input right there, .send. You'll notice that right there. And then, of course, from is from who is this function being called. So let's try to replicate this as well. So we say here, my contract.methods, very important. So we say here, and instead of my contract, of course, we're using contract because that's what we created right here. So we say here contract dot what methods dot what dot create tweet. Yes. Because that's the function that we have in our smart contract. And then what parameters are we providing in the create tweet function? Well, if you look at our function, we have the only thing we're providing is simply just the tweet string. And where do we get that? From the content right there. So we say here create tweet content dot send. So we'll say send. Okay, great. And then we have to specify from who. So from us. So we say from my account. So I say here from, so there's going to be an object here from, and where do we get the account? Well, we have this account right there. So we say here account, and we usually like to get the first account. Okay, right there. So see, and so there we go. So then of course, then this does all that. However, this is all good and dandy. The problem is that here is that it's going to execute this really quickly, and then it's going to move on to the next thing. It's not going to refresh the tweets, and that's the issue here. What we want to do is we want to wait for this to complete in order for us to move forward in our code in general. So this is where await is actually very important. Await, what that does, so basically like what that does is it says like, wait. Okay, now I'm done. So you see, so basically you're waiting for the function to complete completely. And then when that is completed, meaning the transaction has finished on the contract side, then your code will continue. And that's where await is very important. It's actually very important in JavaScript in general. So we say await here, contract the methods.create tweet, we provide the content, the send from, and that is pretty much it. There we go. So we have that. Okay, awesome. This seems to be all good. And at this point, we're pretty much done with all of that. Now, what happens now, let's go ahead and try to actually create a tweet. So we'll say hit connect wallet. Don't forget to do like a refresh sometimes. That way it kind of takes in some of the new code. So we say, hey, connect wallet. Okay, hit next, hit connect. Awesome. And let's go ahead and say, yo, and we say tweet. Oh, look at that. It actually did pop up our wallet. MetaMask, we say confirm, and then it's gonna, continue to load until it's pretty much all done, and then we are all set. So you can see nothing really happening. It's like, even though we tweeted, nothing's really happening now at this point, and that's a problem. And the reason being is that we have this display tweets function that basically will display the tweets or reload the tweets every time. Will reload the tweets every time you call this function. And it's very important right now. So the fifth thing that we need to do is call the function get all tweets from smart contract to get all the tweets. And that's pretty much it. And of course, I also give you some more suggestions on how we can do this. So let's go ahead and get this right there. And this is different now because you'll notice here, this is called a .call function. This is different because .send, that send is like, hey, I'm sending this data. It's like, here, right? This is for you, okay? Have it. Versus .call is, hey, give me the data, right? Hey, give this to me. Does that make sense? Hopefully that makes sense. So when I do a getter function, basically I'm trying to get something like getting tweets, I use .call. When I'm sending something like Spider-Man, right? I am actually just simply doing a .send. So it's very, very important to understand those differences here. So we say my method .call, this gets the data. We just call the method we want to call, and that's pretty much it. So let's use this as a way to do this. So again, let's go to here. I give you kind of some rundown on how you would do this. So I say here temp tweets is equal to, Again, we're using the await. And again, let's do the same functionality. So we say contract, right? Dot methods. So we say here contract dot methods dot what? Dot what? The get all tweets function that we have inside our smart contract, get all tweets. So we say here dot methods dot get all tweets. And do we have an input that we need to provide? Let's see here. Just simply the owner. Who do we want to get the tweets from? Well, that's gonna be us. Okay, so we say here get tweets from us. So I'm gonna say here the user address that's provided inside here at the top, right? That's who I am. So we say user address. And of course, you need to call what? The dot call. So we say here dot call, here dot call, and that's pretty much it. And so let's see if I hit connect wallet. So let's go and make sure we refresh our website here. Hit the connect wallet, and it looks like we're still not getting tweets. Okay, I don't know why, but let's see to the number 6. Maybe number 6 can help us figure this out. So let's go to number 6 here, and our number 6 looks a little bit more like here. So there we go. So set connected is basically when you connect the wallet, it sets up some stuff like the connected section, and it sets up your form. But of course, it also needs to call display tweets. Hey, display all the tweets that we have in the contract. That's very important. So what we want to do is call the display tweets function with address as input. And input, this is a function in the JavaScript code, not smart contract. So I don't want you to confuse this. We're calling the display tweets function in this JavaScript code, not from the smart contract. So let's say here display tweets. And what do we input inside here? Well, the input needs to be what? It needs to be the user address right there. So let's add the user address, which is the one that we have as an input. So we say here address, there we go, hit save. So now if we go ahead and connect our wallet again, let's try this out. Connect wallet, boom, right there. Applause to you guys, good job. And we have our tweet that we saved in the contract called yo. That's right. If we try to not do another tweet, let's just say my second tweet. Okay, let's go and hit that tweet button, hit that confirm button, and now at this point it still probably will not load for a few reasons, which I'll explain here in a second, and mainly because we are not reloading the tweets when we create the tweet. Again, when we create the tweet, now we need to reload again. You can see right there. However, if I go ahead and refresh this page, connect my wallet, there is my second tweet. So it did save in the contract, it's just not reloading, which we can fix really quickly. Anyways, let's go to number 7. So we had number 6. Let's go to number 7 here. All it says is uncomment the display tweets function. It's a pretty easy thing for you to do. And the goal here is to reload the tweets after creating the tweet. So there we go. There's your answer. All you have to do is just simply uncomment this out, save this, and let's see now if this works. So I say here connect wallet, refresh this page sometimes. You need to refresh, hit connect wallet. Boom, my second tweet. Let's do my third tweet. Hit that big tweet button. Hit that confirm. Hopefully this works, guys. I hope this works. Oh, a third tweet is right there. You can see it refreshed the tweets right away. How cool is that? And this icon is actually based on your wallet address right there. It's called Dice Bears. If you want to check this out, pretty cool. There we go. So we've got our tweets, but of course we're not done yet. You're almost done, but we're not done yet. Let's go to our 8th thing we need to do. 8, and there we go. And the 8th thing is about liking the tweet. So of course we can now create the tweet, but we still need to like the tweet. So let's do that. So we say here, call the like tweet function from smart contract. And the input for this smart function is author and the ID. And the goal is simple, save the like in the smart contract. Don't forget to use the await. As always, when we call something, right, we do what? We're saying, hey, this tweet is now going to be liked. So it's going to be a send function. So we say here contract dot what? Dot methods, just how we've done it before. Dot like tweet, because we need to like the tweet. So let's go ahead and do that. So we say dot method dot like tweet. And then what's our input? First one is going to be the author, I believe here. Yes, the author. Looking at our contract. So you say author, and the author is coming directly from our input parameters, comma what? The ID of the tweet, correct? Dot what? Send. And who are we sending this from? From me, from us, from my account. Now, how do I get my account? So we actually have this get account here at the top. You should see this. This is something that you need as well. So I think you see you have this in your exercise. This dot get account. So we say a const account is equal to await. So we say from what? From account of 0. I mean, we've used this before to actually use our first account to send this. And of course, don't forget to use await, very important. So say await to make sure we wait for this contract to finish before we fully update everything. So at this point, let's go ahead and refresh everything. Hit our connect wallet. Okay, great. So it shows us all of our tweets. Let's try to like our third tweet. So I hit like, hit that confirm button. There it is. Okay, wait about 2 hours.
2,000 years later.
And there we go. Our tweet is liked, my friends. So great job on this one, okay? This is, you crushed this. You crushed this. There is our Twitter. And all you need to do now at this point to fully see how this works in, you know, in the full thing, just go ahead and hit that little, I want to say this, I'm not sure what this icon is, honestly, but you can actually preview this whole thing. So open a new window, open it is. There is your Twitter app. I'm going to zoom in here a little bit here. Hit that connect wallet. There are all your tweets. You can make another tweet. Yo, today I made my first Twitter DAPP. Boom. Hit that tweet button. Hit that confirm button. Wait about 3 hours so we can confirm it. As you can see, I do make fun of blockchain sometimes, yes. Because there are certain things where I'm like, okay, we gotta figure this out. Yo, today I made my first tweet. Amazing. We've got a big like. There it is. And of course, you can also like it. So I say like, hit that confirm, and there we go. So the cool part is this is on the blockchain. Your smart contract, your data is on the blockchain. It's not on someone else's servers. It is on the blockchain servers. And that is the cool part about building a DAPP, a decentralized application. So there you go. There is your Twitter DAPP. Of course, if you do have any questions, leave them down in the comments below. Other than that, have yourselves a great day. And do not forget to hit that big like button. I put in a lot of time into this, okay? So you better hit it. Or don't. That's okay too. Now we are going to learn about loops. Now we are going to be learning about loops. Now, hopefully you got the point about loops, but of course, loops is about repetition, repeating things constantly. Let's get into the lesson. Okay, loops. As you can see, we've got some really funny doggies going in a loop. That's what a loop is. I think pretty easy to understand. Now, so again, it's about creating repetitive tasks. You might think of these as functions as well, because function is about creating a task that could be repeated over and over and over, while a loop forces that repetition, basically, is what it does. So think of it as a car. While you press the gas pedal, basically, right, the car is going forward constantly. The second you brake the car, right, the car stops. Basically, the car is constantly listening. Hey, while the gas is pressed, I will keep going. That's the whole point about loops. If you think about it in terms of, car base. Well, of course, we have the same thing happening in programming. So it's actually very, very useful because we do loops a lot. Now, in terms of how you actually create loops, there's a very simple structure that we like to use. So there's a few different types of loops. One of them being for loop. It's called a for loop, hence the word for. And the way it does is you initialize initially with something. So this is the starting point, which could be like, let's say the gas pedal is not pressed initially. So the gas pedal is at position 0, let's just say. And then you say, hey, while the gas pedal is at some position, we will continue doing some logic here. In this case, we're saying, hey, while this variable I, is less than 5, we're going to continue doing some logic, which could be driving the car or maybe adding some numbers, whatever the logic in programming is. As this logic is going on, we're constantly checking, we're constantly updating. Okay, we've done this logic, let's update now. Let's update I++, that's our incrementer, we call it. And then once we update this, we check, hey, is I still less than 5? So if you want to think about this, how many times is this going to actually loop? Well, think about this. Let's say if I is equal to 0, then is 0 less than 5? Yes, it is. So we're going to go to here, I++. Now it's going to become not 0 and 1. Is 1 less than 5? Yes, it is. It's going to go back to the logic and then go back to the I++. Then we're going to go into 2. There we go. And it's going to check, hey, is 2 less than 5? Yes, it is. So now we're going to execute this logic again and then go into the 2++. That's going to be 3 now. Okay, then we're going to say, hey, is 3 less than 5? Yes, it is. So we're going to go into the 3++ now. Then we're going to go into, hey, is 4 less than 5? Yes, it is. Again, we're going to execute this logic. go into the update function. 4 plus plus is going to be now equal to 5. And now we check, hey, is 5 less than 5? And it's not, because 5 is equal to 5. So now we exit this for loop, and then we go about our day. Basically, we're always starting with something. So initialization, then we're checking the condition, and then we are incrementing the condition or decrementing the condition, or we're updating the condition. So, and of course, those of you who don't know, I++ means I equals I plus 1. So we're constantly just adding 1 to that variable. Let's just do a small little exercise right now where we have the sum right here. This is a variable called sum. We're passing in some kind of a variable called a limit, which is the limit of what we're going to be summing up to. And then we just do a simple loop. Of course, as you can see, we have an initialization here of I, that's our initializer, is equal to 1. And we're checking, is I less limit? So let's make the limit, for example, be 3. So now we're checking, hey, is 1 less than 3? Well, yes, it is. So we say sum plus equal to I. What does that mean? That means that simply sum is equal to sum plus I. This is literally just a shorthand for this. And so we say, hey, the sum, which is currently 0, is equal to 0 plus I, which is currently 1, as you can see right there. And so we say sum is now going to be 1. That's the current new sum. Then we go into the incrementer function right there. And now I is going to be now 1, but what? 2, right? So now we check, hey, is 2 now less than equal to 3? Which it is. So we're all good on that. Boom. And now we check sum plus I again. So now we have our current sum is 1 plus what? Plus 2 is equal to what? 3. So now our new sum is equal to 3. Then we go into the incrementer once again. We go from 2 to 3. And we check, hey, is 3 less than or equal to 3? And it is. So now we go into this logic again. And we say, hey, 3 plus I, which is 3. So we do plus 3 is equal to what? 6. And now we go into the incrementer one more time. And our I goes from 3 to 4. And now we check, hey, is 4 less than equal to 3? And it's not. So boo, we exit this function and then we return sum, which in our case is 6. And so that is basically our loop. Loops are kind of harder to understand in general, so it will take you some time if you're a complete beginner, but don't worry, just again, it's all through practice, okay? So let's go through this exercise where we get to calculate all the total expenses of this smart contract. Again, this smart contract is down below in the description below. So just click on that link and then you'll see all the exercises that you need to take. So here is our really cool exercise that we're going to do. And it's basically an expenses tracker. Here's your specific exercise, and it says create a loop to calculate all expenses for the user. And I have a few hints for you, like create a total expenses variable with uint type, loop over the expenses array with a for loop, add up all expenses costs, and then return all expenses. So let's look into actually what this contract does. And as you can see right there, we have a struct that's an expense, and then we have the user who basically made the expense, the description of the expense, and then the amount of the expense. And of course, right here, we have an array of expenses that we have created. In the constructor, this is where we initialize the contract. I have a few expenses for you that we right away start off with, where basically you, as the person who's deploying the contract, is saying, hey, my groceries expenses is $50, my transportation is $30, and dining out is $25. And then we have a function that adds a new expense. Let's just say you add a new expense. You purchase something through a credit card. And then we have another function that gets all total expenses. And this one's really important. This is where like, hey, how much did I spend in total? And so we want to calculate that using a for loop. Again, if you want to try this out, you are going to be a rock star as always, but you can always do this with me as well. Okay. I will still love you very much. All right. All right. So get total expenses. As we know, what we have to do is we have to have a hint for you, which is create a total expenses variable with uint type. So we say here, uint 256 total expenses initially is equal to 0. Just so you know, by default, even if you don't set equal to 0, it will still be equal to 0 by default because that's how it's set in Solidity. Let's go ahead and now loop through the expenses. So I will go through, create a for loop. So we'll say for, there we go. And we will say uint I, let's just say uint I is equal to 0. I should be less than what? Less than the length of this array. So we get this expenses array that we have here. We say expenses dot length. You can see we have that value right there. And then we do I++. Of course, let's go ahead and now create the logic to loop through all the expenses and return the variable. Let's see, so it says loop over expenses array with a for loop, add up all the expenses cost, okay? So we need to do that. So let's go ahead and do add up all the expenses cost. But of course, we cannot just add up all the expenses cost because we're getting expenses for a specific user. So we have to check, hey, is this the expense of the user? So initially, we have to actually add a if function. So I say here, if what? The expenses at this I position, whatever the I position is, could be at 0, could be a 1, could be a 2, dot what? The user, yes, the user who made the expense, that user is equal to the what? The user we're passing in right there, underscore user. Then we need to add to the total expenses. So total expenses plus equal to, again, we're gonna get the expenses at position I, and then just add in that amount. Beautiful. Now we need to actually return this total expenses. So I will say here, enter, return total expenses. And that's it. We've looped over all the expenses and we're returning all the expenses. That's all you got to do. So let's go ahead and test this, guys. Great job, everybody, so far. Yay. All right. Test this out. We got our handy dandy I don't know what to call this, deployment button. We're going to use the Remix virtual machine as always. And just go ahead and hit that deploy button right there. And there is our contract, expenses, contract. Click that little arrow icon. Of course, we have an add expense and we have an expenses to get all the expenses, and then get total expenses for a specific user. Now, as you remember, we created our initial expenses here, right? For groceries, transportation, and dining out for me, the person who actually created the contract. So to get the contract address that was used to deploy, we go to this account section, we hit that little copy icon, and then we go to the get total expenses, and then we just paste in the array address, hit that call, and it says 105. And let's make sure it's actually correct. All right, let's see. Let's make sure that we know how to add, okay? 50 plus what? 50 plus 30 is equal to 80, yes. Plus 25 is exactly 105. Boom! That's what I'm talking about. I love it. So we do know how to add, and luckily the program knows how to add as well. All right, so you've crushed this, okay? And of course, you can actually test out with adding more expenses if you wanted to. So I challenge you to test to add on more expenses and then getting it total expenses as well. So yeah, great job. You crushed it. Hopefully you understand. If you have any questions, just leave them down in the comments below as well. Now what I want you to do is get all the total likes for a specific user using for loops. That's right. You are going to crush this together with me. As always, I have the exercise down below if you want to try this by yourself, but we are going to do this together as well. So here are the 4 things we need to do. Fairly simple, honestly, in terms of what you need to finish. And the main thing is you need to create a function called get total likes to get total tweet likes for the user. Use the parameter called author to actually as an input. You want to loop over all the tweets, sum up the total likes for those specific tweets, and then return total likes. All right, let's get to it. So I'm going to create a function called get total likes. Scroll down, boom, hit enter, and let's type this out. So we say function get total likes. Now for the input, it's going to be address. And I want you to start to get used to using underscore as for parameters. So say underscore author. Why? Because it's a good convention to actually use, good convention to have in Solidity world to use underscores for your parameters. It tells you, hey, this variable is coming from the parameter. Of course, there's going to be an external function. It could be public as well, but because we're not necessarily going to be using this internally, I could just mark this external just to save on some gas fees. And then it returns, what does it return? It returns a uint, that's right. And just so you know, when I say uint by default, even though I say uint by default, it's actually uint 256. So hopefully you understand that. Next, we need to create our total likes variable because that's of course very important. There it is. So we'll go ahead and say uint total likes. There we go. And I can set this to 0, but actually by default, even if you don't set this to 0, by default, it is 0. So I want you to understand that part too, okay? Let's go ahead and now do our for loop, handy dandy for loop. So I say for, we initialize this with uint of 0 because we're going to loop over all of the tweets for that user. Uint I is equal to 0 initially, and I needs to be less than some kind of a length. So the question has become, what length? Well, it's the length of all the tweets. Well, the question becomes, how do you now get all the length of all the tweets? Well, if you look at the mapping here, all the tweets, right? The length of the tweets are actually here, not here. It's here because it's the individual user. That's the one thing I want you to understand. It's the individual user that has the array of tweet structs. So we want to get this specific length, and this is an array. Now the question becomes is, how do you get to this specific array? Well, through a mapping. So let's enter this mapping of the user to get those tweets. So we do I should be less than tweets is that mapping at what? How do we enter that mapping? Through the address. So I say underscore author. This now represents all tweets array. And now we can do the length of that specific array. So I can do now dot length to get that array. Now we want to increment our I. So I say I plus plus, and that's it. Now we enter our logic. We need to go ahead and loop over all the tweets and add the tweet likes to the total likes. So I will say total likes plus equal to what? Again, we need to get the like for that specific tweet. And the way I'm going to do this, I'm going to access initially the array of tweets. So we'll say tweets at the author. This will give me all the array of tweets after that author. Then I'm going to access the individual I. So we'll say I, that's individual index. And this will give me back the struct. And now I want to enter the likes. So I'll say I.likes. And that's going to give me the likes for that specific tweet. Of course, now at this point, it's going to yell at me because I do have to return something. It says a named return variable can remain unassigned. So we want to return this actually. So we want to return the total likes. So we'll say return total likes, and that will solve the issue. Another thing we can actually do is because it says function state mutability can be restricted to view, because we're not really changing anything inside this function. This can be a view function right there. So fairly simple on that side. If you're asking me, hey, Naz, how do you actually understand how to get the specific tweets, and how do you get to this understanding? And it does take some time in terms of knowing where do you get the data. But I always want to think of it as kind of like trees. All right, very important for you guys to understand this. So think of this as a tree. Okay, it's not a tree, but it's kind of like a tree. Okay, it's kind of like a tree. So the tree always starts at the bottom, and then we always go to the top. Yes. At the bottom, that's the root. And then if you want to climb a tree, you have to go through the bottom to get to the top leaf. Let's just say this little leaf that you see here at the top. You have to climb through here, through this leaf, through this leaf, through this leaf to actually get to this specific leaf. That's how I think about data. Data lives on all these different types of leaves, and you have to go through certain branches to get to those leaves. And I always think about, hey, what branch do I need to step on, okay, to get to this leaf? Let's just say I need to step on this one, this one, this one, this one, and then that one to get to that leaf. That's how I always think about basically when I get the data. So that's how I think about mappings, okay? If we look at mappings, for example, think of it as, okay, how do I get a specific like? Yeah? Well, to get all the likes, I have to go through a mapping. So I have to enter the address. So I go through the address leaf, yeah? That will give me all the list of leaves that have, think of it as list of leaves that have all the tweets. So for example, here, the list of leaves that I have all the tweets, yes? And then now I want to enter specific tweets. So I will pick this one, let's just say. And now this one I'll need to get the likes portion of this one. And that's how I will get the likes portion of that. And that because this is a position of I, let's just say I of 0 or 1 or 2 or whatever. So that's how I always think about jumping from one leaf to another leaf to another leaf, or from one branch to another branch to another branch to get to the final leaf. Hopefully that kind of makes things a little bit simpler. Of course, let's go ahead and test this out, guys. Use our handy dandy deployment section. Make sure you clear out all your contracts here at the bottom. That's very important, okay? And let's just go ahead and deploy. So we will say deploy here, and then click on your little arrow icon at the bottom. And here are our functionalities. So let's go ahead and create a tweet first. So we'll say here tweet, yo, this is Naz. transact. Hopefully it transacted. It did transact. And let's go ahead and like the tweet. At this point, of course, the author is going to be me, because that's who I am. So I want to go to my account, get the author, like tweet. There we go. And then the ID I'm going to like is ID of 0 because it's the first tweet. Hit that transact, and that's going to be the I like the tweet. Now we can get the total tweet likes, get total likes by entering the author again. So again, put the author, which is me, hit that call, and we should get 1. If I like again, let's just say, okay, let's say I do transact and like again, and I get total likes now, there should technically now be 2. So there you go. So it does go ahead and get all the total likes for the specific author. Other than that, you crushed this. Good job. All right, we can mark this as a done. Let's go ahead and mark everything done. Boom, check mark, donezo, donezo, donezo. Great job. You crushed this. If, of course, if you have any questions, leave them down in the comments below. Do not forget to hit that big subscribe button. Bye.
I am so sad, you guys. I have no way to make a call. Oh, look at that. We got ourselves an iPhone. Well, check this out. What we just did is we inherited this iPhone. We inherited its functionalities. So now I can make a call. And that, my friends, is inheritance in Solidity. You are inheriting someone's other functionality, a parent functionality to use for your own as well. That is what we call inheritance, okay? Let's take a look at it a little bit more.
Okay, let's go ahead and talk about the inheritance, because it's so important, you guys. And, and it's basically like saying, you are mine, kind of, but also not. So what does inheritance mean? In general encoding, inheritance meaning you are inheriting someone else's functionalities. That is the whole goal, because we can split up different functionalities between different, programs, different classes. And so our goal is to inherit those functionalities. Let's take a look at some examples here. Let's just say you have a car. Okay, you have a normal car. Let's just say it's a BMW, whatever it might be. And every single car has certain functionalities like drive, reverse, stop, correct? So pretty simple ones. Pretty much every single car has that. Hopefully, if it doesn't, that's probably not a car, especially the stopping portion. However, if you take like a truck, for example, a truck has more functionalities than a car. Why? Because a truck most of the time can tow. It can also go off-road more than like a normal car can. So, however, it can still do all the driving, the reversing, the stopping. All the functionalities are still the same as in the car. So what it does is it inherits from a car, a normal car, those functionalities like the drive, the reverse, the stop. Those functionalities stay the same between both cars, but this car, however, has newer functionalities like towing and off-roading. So that's what I think about when I think about inheritance, all right? Let's go ahead and actually think of how do you make this happen in a smart contract. Well, imagine you have 2 contracts, a child contract and a parent contract. And you want the child contract to inherit some functionalities from a parent contract. And the way you do it is you use something called an is keyword. And so you can see right there we have contract, child, is right there, parent, and then you specify the rest of the functionalities. So what it does is it says, hey, I'm going to inherit from the parent functionalities. So the parent I will have all the same functionalities as the parent one on top of my own functionalities, okay? So that's how we think about the child contract. And so now the child actually has access to all the same data as the parent contract. Let's look at an exercise here, for example. This is constantly used everywhere, including especially NFT contracts. For example, if we take in a contract like Azuki, right there, this is a Azuki contract. You will notice this is a contract Azuki, but it's inheriting from a bunch of other contracts like Ownable, ERC 721A, Reentry Guard, and so many other ones. And where they are coming from directly from these import statements right there. So it's importing the Ownable contract, it's importing the OpenZeppelin strings contract, and so many other ones. I'm gonna open this link here. If I open up this link, you will notice, okay, here's our inheritance, and let's take a look at what is it inheriting. It's inheriting an ownable contract. let's go and find that. Oh, there it is right there. And you will notice that it says abstract contract ownable. Again, and this is also inheriting some functionalities, but it adds functionalities like the only owner functionality, which basically creates a modifier for making sure that only the owner can actually call some kind of a function. So it adds a few more functionalities like set owner, transfer ownership, renounce modifier only owner, renounce ownership, and a few other things. So it's literally like its own little program that you can inherit and now use that functionality. Now, one important thing you need to understand here is this abstract right there. And what that means is this is meant for inheritance. It's not meant for a standalone contract. It's meant to be inherited by another contract. That's the goal of abstract, because maybe you want to change the functionalities of the ownable contract, which you can do so as well. And that's how a bunch of these contracts, like NFT contracts, are created, is by a bunch of other files that are inherited from each other. Otherwise, imagine trying to create a contract that is basically just simply, one big file. It's extremely horrible. And you would not want to do that. No. So let's go ahead and go through an exercise, okay? Hopefully you enjoyed that GIF. But let's go ahead and go through an exercise and do some exercising, do some pull-ups, do some push-ups, whatever you got to do, okay? So we have this exercise called a game. It has two contracts. One is the multiplayer contract, as you notice right there. One is a game contract, as you notice right here. And the game contract has some basic functionalities like game name, player count, start game, and join game. The multiplayer contract also has a join game, and it keeps track of what players are currently in the game. So that's why we have two different contracts. Our goal is very simple. Our goal is to inherit from this multiplayer game, because you can have a standalone game, but you can also inherit from a multiplayer game and add on multiplayer functionalities. And so our goal is to inherit from that and add on some more functionalities. I want you to go ahead and inherit from the multiplayer game, step 1. Step 2, call the parent join game function. Why? Because right here, this one has the join game function that has its own functionalities. It also needs to call the parent join game so that we can keep track of the players. So it's like two functions that are the same name, but they can actually keep track of different functionalities in themselves. And then finally, increment the player count in join game function in the game contract. So of course, as always, you're welcome to this by yourself. If you do so, you're gonna crush this. Otherwise, let's go ahead and do this together, because I'm excited to show you how we make this work. As always, whenever you go ahead and inherit from a contract, you will use the keyword is. Like this is. So we say is multiplayer game. Awesome. And now we can actually use those functionalities as well. So inside here, the second thing we need to do is we need to call the parent join game function. You might have to use something called a super keyword. So let me tell you what the super keyword is. It means you become the Superman. Super means call the super contract. Call the function from the super, call from the parent contract. So if I say super dot join game, it's actually going to call not this function. It's going to call the parent one, which is the multiplayer game function. That's what the super is for. And you can actually see this in a lot of examples, especially inside NFT contracts. So this way we still call the parent contract, but now we keep track of our own functionalities. So for example, this is functions from parent contract. And now we add our own functionalities. Add our own function right there. Add our own function. And so in our own function, we want to increment the player count to join player count in join game function. Let's go ahead and do that. So we have our player count, pretty simple. To increment it, all you gotta do is just say player count plus plus, and you're all dandy. That's it. We've incremented the player count and you're all good. So as always, let's go ahead and test this. Don't forget about our handy dandy little, what is this thing, deployment section. Let me go remove this and click on that section right there. We are using Remix, of course. To deploy, you can see actually that we have this little arrow. And because when we deploy this game, you'll notice that it has an input called game name. That's right. So whenever you have an input in the constructor, well, actually, you will have to deploy with a specific input. So for example, my game input is going to be the NAS game, whatever you might want to call it, right? Hit that transact, great. Now it's going to deploy our contract, and here it is at the bottom right there. And now we have the functionalities like game name, of course, which gives us the name of NAS game. We have the start game, the join game, and so forth. Now, let's go ahead and try to run the join game. And you will notice, check this out. This is really cool, okay? You will notice here that we have this players, yes? But the game has no players anywhere inside there, right? So it's nowhere, it's nada. But where's players? Players is actually inside the inherited contract right there. So that's how you can see that's actually inheriting its variables and even its functionalities. So players it is, and there it is, players. Pretty cool, huh? So let's go ahead and join the game. Looks like I already joined the game, so a player count should now be 1. Let's go ahead and select a different user here. Let's join the game again as well. And now the player count should be 2. Perfect, yeah. And of course, if you want to check if the user is actually in the players, we can copy this, go down, paste in our address, hit that call, and we should get true. Right? So what we have done is we have this multiplayer game that we're inheriting from into our game, and so we can use its own functionalities. Pretty cool. You will start to see this a lot more often as we continue to build more contracts. You crushed this. Let's go. Peace. Hey, yo, you know what we're gonna do now? Yeah, we're gonna use inheritance, my friends. We're gonna inherit from another contract. That's what we're gonna do. Are you ready? I hope you are. Hey. Oh, you gotta have fun. Awesome, guys. So, as always, now we are going to use inheritance in our Twitter contract, but just replacing a simple functionality. So you have created this functionality called the only owner modifier, and you've learned what that is. So congrats to you. But we're actually going to replace this. We're going to delete this with another modifier that's from a contract called Ownable. So one of the most popular contracts out there that you need to know is from OpenZeppelin. So OpenZeppelin is actually a security company. They are a secure blockchain company, and they do make contract standards. And one of them is ERC 721. Within that, they have the ownable contract. So check this out. I will go ahead and say OpenZeppelin. Okay, I suck at spelling this one. OpenZeppelin, there we go. And then ownable contract. So you can search that up on your own Google. And so it should pop up with this GitHub right there. Let me go ahead and zoom in for you. So there's our code for an ownable contract. And you notice here, this is a contract. It's an abstract contract, meaning we can actually import this contract and replace functionalities as well. But you'll notice if you go to contracts, for example, there's all these contracts they give you access to. If you go to token, there's our ERC 721 contract that you will learn, of course, as well. And this is where you create NFT standard contracts. But the ones that we're going to use today is actually the extension of ERC 721. Let me go back to, we're going to use simply the access contract. There's an ownable right there. And in terms of code, let's check out what the code is. Pretty simple, actually. We can see that we have an owner. So there's a specific owner of a contract. We can see that when we deploy the contract, it actually transfers ownerships to the initial owner. And then we can see we have the modifier. The modifier, the one that you created yourself, this require message.sender equals owner, is actually in here as well. You can see it calls this function called check owner, which if we scroll down, there it is. Require owner is equal to message.sender. Like literally the same thing as what you created, but they made one of their own. The benefit to using this one is simply because this is a standard for ownership contracts. That's it. That's the only benefit. And it has some extra functionalities that you can use as well, including things like renounce ownership, including things like transfer ownership. Very, very useful things. And so what we're going to do is we are going to import this contract into our contract. Now, how do we do that? Well, to do it, all we have to use is you have to use an import statement in Remix IDE. So if I say import here, I can actually, over there, you can see I can specify OpenZeppelin. I can do @OpenZeppelin, right? / It will right away tell me exactly, hey, what are we going to import from? Well, we are going to be importing from contracts folder. Inside the contracts folder, there's the access folder right there. Yes. Inside there is ownable.sol. So there you go. And so we have now imported actually this ownable contract from OpenZeppelin because it's so well recognized amongst the community that Remix actually gives the ability to simply just do this. Hey. So now, of course, we're not done yet because we need to inherit it. And from what you know at this point, how do you inherit this? You use the which keyword? The is keyword. The is keyword. Good. So we will say Twitter is ownable. It's probably going to give you some errors. Trying to write non-virtual modifier, did you forget to add virtual? So the reason why is because we have modifiers as well, and we have owners. So we actually have competing things here. We have to remove our owners, remove this one, and we have to remove our modifier, this one right there. We have to remove our owner, right there, not necessary. We can even remove this constructor since we're not really doing anything with it. And there you go. And there is that. And you can see now you have no errors. And the only owner modifier that we have, where is it? Where is our only owner? There we go. On the change tweet length still exists and it still works because why? Well, the contract from OpenZeppelin has a modifier called only owner. Again, the exact same code as what you had with some extra functionalities. And so now if we deploy this actually, check this out. Handy in deployment section right there, as always. Hit our deployment to deploy. There is our contract. Point down. And you'll notice here we have things like who's the owner. Yeah, the owner is the one who actually deployed. We have also things like transfer ownership. So I can transfer ownership to another contract, right? And this function is coming from where? Well, it's not magic. It's coming directly from here. We have a transfer ownership contract directly inside, right there, inside ownable.sol. So there you go. Congratulations, you have done this, my friends. You have crushed this. Yeah. Peace. Bye. Adios.
Hi, can I please order a pizza? Yeah, sure, yeah, what do you want? I want a pepperoni and pineapple. Yeah, we don't have pineapple. What do you mean you don't have pineapple? No pineapple. Do you still want it? Fine, bye. So that, my friends, is called person-to-person communication, contract interaction, where two contracts can actually talk together. That's right, share information, share data, and even call each other's function. Pretty crazy what's possible. Let's check it out some more.
So let's talk about that contract-to-contract interaction. You've got two separate contracts running on the blockchain. How do they talk to each other? We don't know. Well, let's check this out. Hopefully, I think that's pretty funny. Baby, come back. It's like he's talking to someone, and of course, you know, you're talking to someone, they're probably talking to you. So again, this is the whole point of contract-to-contract interaction. How does that work? Where if you think about let's just say a contract called game and a contract called user, they have a lot of interactions between them because a game, right? A game uses a user contract. A game is in charge of the gaming aspect, but a game also takes care of the users. So a user contract might take care of creating a user, deleting a user, increasing the level of the user, while a game might be in charge of starting a game and playing a game. And so what happens is that those two contracts talk together to call each other's functions and to even update the data. So for example, the start game function might also create a user at the same time by calling this contract. So how does that work? If you have a contract A and a contract B right here, you notice here this contract A has some data and it has a set data function that sets the data. Fairly simple. Contract B, however, does not have that data. Instead, what contract B does is that it defines this contract A right here. It defines this contract A and then it uses the contract A that set data to set the data inside contract A. That's right. So that's pretty cool. Now, how does that even work? Because what happens is that you actually need to define an interface. So an interface, we'll talk about that here in a second. That basically is a definition. It's almost like a blueprint for contract A. It says, hey, this contract A has these functions like set data and data that contract B can use. And then what we do is we set that as a type. So we say contract A, which is the interface. Public is contract A. And then we specify the contract address for contract. So this contract, of course, is a different address than contract B. And so we specify that contract address, and that's how we create that connection right there. Then once we have the connection, now we can call the data. We can say contract A dot set data to basically just call this function from this contract. What is an interface, you might be asking, because you saw it right there. Yeah, right here. An interface is simply a blueprint. A blueprint, as we know, is a blueprint for a house, right? It specifies here, we have this many rooms, there's this room, and in this room, we're going to have this, whatever it might be. That is a blueprint. The same thing happens for an interface. An interface is a blueprint that says, hey, you're going to use these functions. And this is very important because imagine NFT contracts, right? NFT contracts, there's a blueprint on how to create an NFT contract like the ERC 721. It says, hey, you gotta have these functions, the mint functionality, the burn functionality, and so much more. Okay, so that is why blueprint is so important. So as you can see right there, right, we have this interface right there, contract A, that simply has the data, set data, all the blueprints for what that contract A is. And so now contract B uses this interface to talk to contract A. That's it. Let's go through an exercise, my friends, at this point. Okay, this exercise consists of two specific exercises, the user exercise and the game exercise. Why? Because they are two separate contracts that are going to be deployed to the test network. So wherever you're looking for an exercise, you got to look at two exercises, each of them called an interaction exercise. So the first one is called the user exercise, and this one is very simple. You have this user contract that specifies the player, the players, and a function to create the user or the player. In this case scenario, your goal is very simple. Create a new player and save it to players mapping with the given data. And what data do we have? The user address, and we have the user name. That's right. So what are we going to do? Well, let's just create the player. So we're going to create a temporary player by saying player, new player is equal to player, and define the actual data in here with the struct. Now, when you specify a player, a struct, you have to say that it's a memory. So this is going to be a temporary player stored in memory. Then inside that you specify here, what data are we going to specify? Well, the player address, the username, and the score. So the player address is going to be like this. So player address, yes, is what? It's the user address, this one right there. So we'll say user address. Perfect. And then we've got what? The username. So now we say username. User is what? It's exactly the username that's here, right there. So we say username is username. And then finally, the score is what? The score is going to be by default just simply 0. And there we go. We defined our new player. And don't forget our semicolon. Of course, that's always very important. And so at this point, that's pretty much it. But we now need to add this player to what? To players. So we'll say here players. Yes. Now specify what? Players at what address? So the address is going to be what? The user. Yeah, the user address, right, is equal to the new player. There we go. And there it is. So for this specific address, we have a new player that is this right there. And that, my friends, is pretty much it. Now, really important for you to understand here is about this require statement. And just think about what that means. We're saying here, require the player's user address, that player address equals to 0. What does this mean? We want to make sure that this user has not signed up yet. We want to make sure that the address of the user, whoever's trying to create this user, has an address of 0, meaning it has not signed up. And if they have signed up, they're going to have a different address that's not 0, and hence why we'll have an error called user already exists. Perfect. So we got the user now. Let's go to the second one, and that's going to be the game contract, the interaction game contract. And here we have the interface, of course, we have the game contract, and so forth. And there's 2 things we need to do, right? 2 and 3. First, set up a connection to the user contract through iUser in constructor. Let's do that first. To create that connection, all we say is we say user contract is equal to, and then we say iUser. Again, we're using that interface, iUser, and specifying the user contract address that's given to us right here. That's going to come from the constructor. So whenever we launch this game object, this game contract, we're going to define that in the launch code. Perfect. That's good. Now for number 3, call the create user function with the correct input. Fairly easy. We've got this user contract. To actually use it now, we say here, user contract dot what? Dot create user. Oh, and look at that. It right away filled in everything for me. Create the user address with the user address. But the user address is coming from where? Well, it's not the actual user address. It's message.sender. And then we've got the username. Now, very important thing to understand here, okay? And listen very closely. Check this out. Here's what I want you to understand. This is very important that we send over the message.sender inside the game. Because if you do it inside here, let's just say if you were to do this message.sender inside your user contract, well, what do you think this is? That is the address of the game contract, not of the user who's interacting with it, but the game contract. So that's why it's really important to specify the user address in the input and not just say message.sender, because the game contract is the actual one that's talking, right? That's talking, what's up to the user contract. So hopefully that one makes sense. At this point, let's go ahead and deploy it and see how this works. I'm pretty excited for this, guys. All you gotta do, as always, is go to our deployment section right there on the left side. And I'm going to clear out all your other contracts. So just hit that clear button. You can still be on the remix environment. It's completely okay. Now we are going to deploy the user first. First is going to be this user.sol, interaction user. So hit that deploy button and it should deploy here on the bottom. And you should see this user right there. Okay. Now, second one is let's switch back to our game. There it is. Here's our game contract, the one that we've just fixed. And now we want to deploy this one. Again, go back to our deployment section. Boom. And now in the deployment section, you see it says remix Shanghai. Make sure it also says the game. Yeah, the game. Great. And we're going to specify, hey, at what address are we going to deploy the user contract? So here we have our deploy user contract. There it is. So we're going to copy this right there, this big button, paste it into our deployment script. Right there. That's our input for the constructor. Yeah, this constructor. Hit that transact. Looks like it all went through. Boom, chicky peeky. And now we've got our game and we've got our what? Our user. Now let's try to actually interact with it. So I'm going to create a username here. Now, and I'm going to say here, Nazar, hit the transact button. And of course, there he is. It looks like it's all been created perfectly. Awesome. Sweet. Now, let's check if this one has been created inside here. So specify go back to the user contract right here. And now let's check here for the user contract. Copy our contract address, the one we created with. Paste it into the players. Hit that call. And boom! Check this out, guys. We've got Nazari for the username. Here is our contract address. Score is 0, but we got the username. Again, this is a completely different contract deployed separately. They're 2 separate contracts deployed. Yes? And they're talking to each other. Well, mainly the game one is talking to the user contract. But you notice here, and if I try to do it again, it should give an error that says user already exists because I cannot create 2 of the same users. So how cool is that? I mean, I think it's so cool because there's so much to learn here. There's so many different things you can potentially do. And to me, it's always like, what? Anyways, great job, everybody. Don't forget to smash that like button, and I'll see you later. In this lesson, we are going to be now creating an interaction between the Twitter contract and a user profile contract. That's right. We're going to make a requirement to make sure that the users who are using your Twitter contract and your Twitter app actually have a username and a profile. So this exercise actually has a few different things. Now, if we scroll here to the left side, you notice here it is at the bottom, it's kind of a little bit small, but it says Twitter interaction exercise user. Again, everything is down below in the description if you want to go ahead and check it out, okay? So click on the user first, basically, and you'll notice here that this user has a few different things that we need to do, right? We've got this user profile, right, that has like a get profile function, a set profile function, and we have a list of user profiles right here. The main important thing is we have a struct called user profile. This is a struct that takes care of the display in the name, the display name, and the bio. And so we just simply are mapping your address, which could be your wallet address, to your user profile, and that's it. And if you've done that, meaning you've set the profile, that means you have the account in Twitter. That's right. Now, how does Twitter now work with that? Well, if we go back to our Twitter integration, the main contract, this is pretty much the same contract that you currently have. And this contract now, at this point now, our goal is to integrate that profile into the Twitter contract. Number one, let's start out with this. Let's go back to our user, and inside here we have a few things that we need to do. Actually, just one thing. Save user profile to a mapping in the set profile function. Don't forget to set the display name and bio. So inside here we have the set profile function, which is basically like registration, and we actually need to save it in the user profile right here, the profiles mapping. To do, all you gotta do is we get this string display name and string bio as an input. We need to use it to create and add the user profile to this mapping. All we gotta do is to say profiles. Again, this bracket is saying, hey, what is the address that we're gonna say this profile to? It's gonna be saved to the address of message.sender right here is equal to what? A new user profile that we need to create. So we need to say user profile, and inside that we need to specify two things. One, display name, and two, the bio. So I'm gonna say here underscore display name, comma, underscore bio. Whenever we call the function set profile, it's going to save the profile for that specific user with the display name and the bio. And that's it. That's pretty much all good and dandy right there. And if you want to test this right now before we actually go any further, you can do that by simply going to the deployment section right here. So let's go ahead and deploy it here using Shanghai. Make sure is always to clear out those contracts so it's all clean. Just go ahead and make sure it says exercise user and hit that deploy. Scroll to the bottom, hit that down arrow, and let's go and set a profile here. So here, I'm gonna say here, the profile is gonna be display name Naz Dumansky. That's my usual profile, and then bio, smart contract developer. Boom, hit that transact button. And if you get this green, that means you're all good and dandy. Yes, these are all good and dandy. And you can actually check the get profile, but just simply adding it the user address. So we can check the user profile by going up to the account that you use to deploy, and then putting that into the address and hitting that call, and that should get you Naz Dumansky and the smart contract developer for the bio. Now you notice here, very interesting actually, I want you to understand there's the get profile and then there's the profiles. Why is that the case? Well, that's because Naz, okay, that is because that's just life for you. That's how it works, guys. But no, not really. That's not how it works. The reason why is there's a logical explanation to it, which is this mapping or this profiles mapping by default is public, guys. Whenever you have a value that's public in smart contracts, by default, it has a getter. That's right. By default, there already is a getter function. So if I create a string, for example, string max supply, and it has some kind of a number equals to 50, for example, that has a getter that I can actually get. Same thing goes with mappings as well. By default, everything that's public comes with a getter function. So we don't really need the get profile function in this case, but it's okay to have it there for now. We got the user profile all working. Let's clear this out, hit that big X arrow. And now let's go back to our main contract. So let's go back to our file explorer and let's go to this main contract right here, main.sol, and click on that. Now, this is a little bit more complicated now. And if you are welcome to try this, and I highly suggest you try this by yourself, because honestly, this is the best way to learn is to challenge yourself, guys, okay? Without challenging ourselves, we do not learn, period. So anyways, second thing we need to do is, in this case scenario, what we want to do is, we'll think about this. We have this user profile, and we are giving you the ability to create tweets, to like a tweet, and to unlike a tweet. Shouldn't you be a registered user to like create a tweet? Just like now on Twitter. In order for you to tweet, you have to sign up to Twitter. Same thing happens here. And like in order for you to like something, shouldn't you also be a registered user? So what we want to do is create a modifier. And remember, a modifier can be used in many different places to make sure that the user who's trying to call a function like create tweet, like tweet actually is a registered. First things first, add a get profile function to the interface. Oh, interesting. Well, we get this interface, and remember, what is the interface, right? It is a blueprint for our contract, the user profile. It is what's going to allow our Twitter content to know, hey, we can call this function and we can call the next function. So the function we need to add is called get profile, because that is what user profile has. So let's go ahead and do that. This is simply a blueprint. We're not defining anything here. We're just simply saying, hey, here's the input and here's the output. Function, get profile. And what is the input for this function? Well, a few different things. It is an address with an underscore user. What is now the output? It is public view returns, right? So we can actually just simply copy all this stuff. So we can say public view returns user profile, just like that, honestly. Go back to our main here. Public view returns memory. And that's it, guys. See, all I did was I copied and pasted the definition. Now you might get an error here that says, let's see here, says functions in interfaces must be declared external. This is very important here. Change this public to be external. The reason why is because by default interfaces are called externally. Remember, an interface is something that defines a blueprint. It will be used by other contracts, right? It's not like will use this internally. This get profile function will never be used internally inside this interface. It does not work that way. You're not gonna create any functionality inside here. It does not work that way. However, you are going to call this get profile function by the Twitter contract. So that's by default, all functions have to be external inside interfaces. We got that. That's check mark. So we can do white check mark. There we go. All good. Ba-bam. Next one, initialize the iProfile in the constructor. Remember, in order for us to connect to this user profile that's going to be deployed in a different address, we need to connect to with a contract address. And to do that, we need to initialize it in the constructor. So let's go ahead and create a constructor first. Again, inside here, let's scroll down, and we usually create a constructor right before functions start. Okay, so say constructor, parentheses, boom, brackets, and there we go. Inside here, we're going to define an address here. So say address underscore profile contract. This is going to be the address of the actual profile contract that you will deploy, right? Don't forget to include the profile contract address as an input. Great. Now, once we've done that, inside here, let's initialize it. So we have our profile contract here, but it has no value. So to initialize it, we say profile contract is equal to iProfile with the specific underscore profile contract address. There we go. And so this will now initialize and will create the connection to the user profile contract in general. So we've got that. Let's go ahead and mark this to be the check mark. Boom, boom. Hey, got it. Fourth thing, create a modifier called only registered that requires the message.sender to have a profile. Now this one's really cool, right? Remember, we've created other modifiers before. This one's a little bit different, okay? Called only registered. So how do we create a only registered profile, only registered modifier? After this events, I'm gonna say here modifier, parentheses, boom, brackets. After this modifier, we're gonna give it a name. So I'm saying only registered. And now inside the modifier, we need to use the get profile to get the user number 1, and 2, check if the display name has a length of less greater than 0 to make sure the user actually exists. That's right. So first you need to actually use this getProfile function to say, hey, is the message.sender isn't actually a user or not? So let's do that. We're going to create a temporary user profile. So I'm going to say here, iProfile.userProfile, because that is what the struct is, right? Memory. So again, memory means we're going to save this in temporary memory. Is going to be called user profile temp, let's just say, is equal to, right, is equal to profile. Let's use the profile contract dot what dot get profile, and we need to specify a what, some kind of a message dot sender, like so. And so there we go. This should be like this. Now you might get an error that says modifier by does not contain this. The reason being is because always in modifiers you have to specify where the rest of the code will run. So you have to specify, hey, basically we're gonna check this first, and then run anything else needs to be ran wherever this modifier is being applied. That's right. So good. We're all good on that side. So we've got the profile. And now what happens when you actually get the profile? Well, by default, let's go back to our deployment section here. Okay, I want to show you something really quickly. So let's go ahead and actually, let's go back to our user contract. Let's deploy the user contract one more time. Just go ahead and go back to the deployment section right here. Boom. And then make sure you're on Shanghai, make sure you are on the user section, hit that deploy, okay? What happens if I try to do a get profile on a random user that does not exist yet? Go ahead and put in a random address. You can just put in your MetaMask address, okay? Let's just say put that inside there, boom, right? Get profile, hit that call, and you can see what happens here. Pretty much there's nothing, right? It's technically pretty much nothing. It's the string, they're both strings, right? And there's nothing in those strings. As you can see, it does not give you an error. It simply just gives you an empty string. So you have to think about how do we now catch that? Now, because it's an empty string by default, that means we have to check if that string is empty. And only if it's empty, then that means the user profile does not exist. So let's go back to our main contract, okay? Let's go to our file explorer right here, go back to our main contract, boom. So there's our main contract. We're back to this. Now I'm gonna check. We're gonna create a requirement. Say require what? Some kind of condition, right? Now you cannot simply say require user profile temp to not equal to null, which some people might know, like, you know, that's what you do in like JavaScript and stuff like that. You don't necessarily do that here in Solidity. It's a little bit different here. So we wanna, let me copy this just so I make sure I get this right. To actually figure out if this user exists or not, we need to get one of the attributes. Let's just say display name. So we say this dot display name. So we got this display name from a user. Now we need to make sure that the length of the display name is greater than 0, because it's going to be an empty string if the user does not exist. To get the actual length, we need to use something called bytes. Bytes, right here. The length, like so, needs to be greater than 0. Otherwise, if this condition is not true, we will just throw in an error and say user not registered. Again, the reason why we need to use bytes is because you cannot just do this, the display name, the length. It doesn't work that way inside smart contracts. You have to use the bytes to figure out how many bytes there are, and 1 byte approximately is 1 character, okay? So we say bytes, the length is needs to be greater than 0. As a result, you know, otherwise user is not registered. So this modifier will make sure that this user actually does exist. Okay, all great. You got that done. So hopefully you understand that. Of course, if you have any questions, leave them down in the comments below. Let me go ahead and check mark that right here. Boom, check mark, done. By the way, if you're wondering what kind of a tool I use for these emojis, it's a tool called Rocket. Really cool tool. Final thing, 5th, add the only register modifier to create tweet, like tweet, and unlike tweet functions. So let's go ahead and do that. And how do we add that? As we've done previously with the only owner, right? When we create the tweet function, we say public only registered. And what's going to happen here, it's going to call this function first, the only registered function first, right here. It's going to call the only registered function, this modifier first, go through this, then only this is all still good, then it will continue the rest. Otherwise, it will just throw an error like this. So we got that. That's all good. Finally, after creating a tweet, we want to do the same thing also for liking the tweet. So let's go ahead and add that inside here as well. So like tweet, only registered as well. Same thing goes with unlike tweet, also only registered as well. And that is it, my friends. You're pretty much all done. Now, the last thing I want to do is let's just go ahead and test this because I'm pretty excited for you to see what the result will be like. All right. So first is first, as always, we need to deploy the smart contract for the user profile. Again, let's go back to here. Again, let's just clear all this out. I want to keep it clean for everybody here. And we're not doing this one. So you can see we're not seeing the user contract first. That's how we need to go back to our file explorer and then make sure to select the user right there. So we say user right there. That's the one. This is our user contract profile. Make sure this is all good. Make sure it gets a green check mark here. Boom. Let's go back to our deployment section. Shanghai. Make sure this is all good. And again, double check that this user here is like that. Again, reason, guys, why I double check so many times is because as a coder, you just have to be good in details. You do. I'm sorry. You have to double check things, triple check things, quadruple check things, fiftuple check things, like as many times as you possibly can. Trust me. This is why I double check so many times. And as annoying as it is, as much as you don't like it, that's the hard truth of being a developer. You have to be good in details. You do. Especially when you want to be good like a senior developer. You just do. Anyways, let me go back to here. We need to go ahead again, make this the user. Deploy now. And we should get our profile contract on the bottom right here. Great. Let me go ahead and do this. Now, at this point, don't touch anything. Just copy this smart contract address. Just hit that big copy button right there. Boom. See that big copy button? Hit that. Great. Go back to File Explorer. This one. Select our main contract. This one. Awesome. There it is. This is the one we just built, okay, for the Twitter contract. Go back to our deployment section. And at deployment here, we should see right here says iProfile. Don't select the iProfile. Select the Twitter. This one. Select the Twitter main.sol. Very important. Make sure it says Twitter right here. Okay, that's the one we're going to deploy, not the iProfile, the Twitter one. Now, you can see here now it says deploy. Yes, but we have an input here for the address, for the profile contract address, because we're going to deploy and then we will right away connect to the user profile contract. So paste in that user profile contract address we just copied. Oops, sorry. Here it is. And let's hit that big transact button. Boom. Hey, and let's see here. What do we get? We get a big green check mark right there. Awesome. If we scroll down here on the left side, we should see both the profile and the Twitter. So in the Twitter now, there it is. There's our thing. Boom. All is good and dandy, as you can see. And you can see here, we get the get tweet function. We got the owner. All is awesome. At this point, let's try and create a tweet as just a random user. So we say create tweet. Let's go ahead and again, give it a string here. Hello. Let's hit that transact. What do you think will happen if I create the tweet? Oh, look at that. User not registered, you guys. That's right, because the user is not registered in the user profile. Very interesting, right? So we got that error. Now, to actually now register a user, we don't register it here in the Twitter contract. No. We register it here in the profile contract. So we go to the profile contract here and we do set profile and we use our address that we currently are using, this DDC4, whatever it's called, and we give it a name. Let's just say Nas, bio, smart contract developer. Hit that transact and you can see it created that user. Now we can create a tweet because we have created a profile now. See, now that makes sense. Okay, so let's scroll it down the left side right here, back to our Twitter contract. Boom. Inside there, all you gotta do, my friends, is create that tweet and be like, yo, and hit transact. And let's see the magic happen. Watch this. Oh, look at that. It did its job. It did it. You see, this time it did because we created this user profile beforehand. So that was the cool part. I want you to understand. These are two contracts, one on the left side, one on the right side, deployed separately to the blockchain, and they're both talking together. Okay. So I love this kind of stuff. I enjoy this kind of stuff a lot. And that's it. You've crushed this. Hopefully this makes sense to you. You can go ahead by yourself, try to like the tweet and unlike the tweet as well. But you can see that how two contracts can talk together. And again, I wanted to cover this because this is something I honestly didn't know when I first started, and it's something I was questioning all the time, and how contracts talk together. Well, technically the whole blockchain can talk together. So hopefully that makes sense to you. Hope you have a great day. Don't forget to hit that big subscribe button. I really appreciate it so much, as it allows me and it just makes me so happy and it gives me joy to make more videos like this. So have yourselves a great day. Bye. In this video, we are going to be adding a user profile creation to our Twitter project, meaning we want to require a user to have an actual profile with the username in order to be able to create tweet. So let's check out what this means. As you can see right here, that I have this app called the Twitter DAPP, and right here, if I connect my wallet and if I connect with my MetaMask, of course, you can see if I have no user profile, it will ask me to create my profile with the username and bio. However, let's just say that I do have a username and profile. Let me go ahead and switch to another account here. I'm gonna do account 1. Let me refresh this here. I connect wallet to account 1. You can see it knows my profile, so hence it goes straight to what's happening and I can add my tweet. That's great. But let me go back to the profile where I don't have anything. So I'm gonna go back to the account that I do not have anything. So I'm gonna switch to this one. Hit refresh. There we go. Connect wallet 273. Awesome. So now in this username profile, I can actually add a new username. Let's just say Nazari. Okay, and I can say smart contract. Did not know how to type on these live videos. Developer, as always, developer. Hit create profile. It will ask me right here, because it even has a nice loading animation right there. It will ask me to hit that confirm. I hit confirm and just give it a second, or even give it a few seconds, because as we all know, we all know how slow sometimes blockchain is. Tea is good. By the way, if you're a tea drinker, let me know down below. And there we go. After we've done that, it says connect to Nazari. It has my user profile, right? A username, and then now I can actually create tweets. I can say yo, for example, right? I can make that tweet, boom, right there. Hit confirm. Again, it's gonna take some time. That's just how life is sometimes with the blockchain side. Yes, we got it. So there it is. There is our tweet, and there's our Twitter DAPP. That's pretty much it on that side, right? So we have our user profile creation. Now, let's look at the actual exercise. It's written in Code Sandbox right here. And of course, as always, everything is down below in the description. So if you want to go ahead and check that out, it's in this big GitHub page. So go there and click on the correct exercise. This one is in React.js. And I know you're like, Nas, what the hell? I don't know how to React. You're crazy, Nas. Don't worry about it. You'll be fine, okay? The more you get exposed to different technologies, the more excited you will get in general. For me, I did it very simple for you guys. You just simply have the most basic stuff around Web3.js in order to actually finish this project. However, I will go through it so you understand what's going on in the React.js world here, okay? So as you can see here, we have the source folder, we have this app.js, we have components folder, and everything starts from this app.js. This is our React.js content. And this right here, we call this JSX, but I think of this as HTML. Okay, this is React.js HTML version is what I'll call this. And there's a lot of stuff going on here. For example, we have our div class name called container, we have our H1 Twitter DAPP, and then we have our connect component that takes care of everything around connecting your wallet. And if you go into the connect wallet section, you'll notice here that this is basically its own little app, right? That's the whole point of React is you can build big applications. And this app, as you can see, is in charge of simply connecting your wallet. And if you're connected and you have a username, it will specify basically your username. And if you don't, right, it says please connect your wallet to tweet. So this is in charge of all of that. Then we have another one here. We go here. We have this loading state and the account profile exists state. Basically, if your profile exists, then we have this add tweet. I call this component. And then this one, this component is in charge of the submitting a tweet. So if you want to add a new tweet, here's your text area, here is your button, here's your form. And you notice here, everything in React.js is in the return. So in terms of HTML, it's in the return in these parentheses, because that is how we return JSX. And the actual logic for everything in terms of JavaScript wise is above that return. And this is where you can create functions and specify use state variables. And those of you who do not know, use state variables are really cool because it's like having a database for your app, a local database for your app. The cool thing, and then different components can read that database. And so you can have a user profile, right? If you're thinking about Facebook, for example, if you're thinking about Facebook, you have a user profile, and so it maintains that state, right? It maintains your user state. You don't have to log in every single time into Facebook. It maintains your state constantly. So that is the big benefit of something like use state here. All right, so we have that right here, use state. On this basically says, hey, the value of this loading is false. The value of this new tweet is nothing here. So we went through this one. And then finally, this one right here is if your account does not exist, let's just say you have no user profile, we have this profile creation component that is in charge of that. And this is where you enter your username, for example, right? This is your input. You enter your bio, right there it is. And then there's your button for creating a profile. You can see here, create a profile. So very general, you can take some time to look through this yourself, try to figure it out. If you do know React, then you're Gucci. Let's walk through what we need to do to make this fully work, because right now you can actually open this up separately. So I like to open this up in a new window. That's my exercise. There's a Connect wallet. That's our exercise. And that's it. And I'm going to read through what we need to do for this Twitter DAPP. First one is finish the get profile function to check if the user exists. That's right. So we have this get profile function. So it's inside here, this check profile. This check profile, as you can see, calls the get profile. And this get profile is in charge of getting the username from the smart contract based on your wallet address. Again, this is based on the account address that you have inside here. So we need to use the get profile using get profile function from the contract and then return the profile display name. Let's create a const here. Const profile is equal to what? Equal to something.get profile. Now, what is that something? What is that contract? Well, let's look through our use state here. And we notice here that we have this profile contract and then we have contract, right? This contract is simply a contract that will be set up later on, will be initialized with Web3.js. This profile contract will be initialized later on for the profile. When they're set up, we have access to the whole contract. And so just like in Web3.js, if you look at Web3.js, call contract method or send contract method, you'll notice here, my method.call, there it is. Yes. So we do my contract.methods method, and then we do .call to call that contract method. So let's do that one in our React application here. So let's go back to our get profile is equal to, right? Equal to what? Profile contract dot methods dot what? What is our method of our profile contract? Well, let's go back to our profile in Remix IDE. There it is. And it is called get profile. And the input here is the user address. Okay. So let's go back to here, dot methods, get profile. And in the input, we have the user address, and the user address actually is stored in the account. So this account right here, this account is stored, this user is stored in the account. So let's go back to our get profile. We say account here, right? Dot call, and that is it. Oops. This will call our get profile function. However, you have to wait for, because sometimes it takes some time. It might take a few seconds, right? And that's why you have to do this await thing, right? We talked about this before, to make sure we wait for this to complete before moving forward. Now that we have our profile inside here, we need to return the profile display name. And the only way to do this, we just say return. The profile is going to be the whole object. We say profile dot display name. Profile dot display name. This will return to us the display name in general. We finished the get profile function. Let's go to the next one here. We need to complete the create profile function in the profile creation.js to create profile in your user. Okay, no problem. Before we do that though, I'm gonna switch it up on you a little bit here. I want us to actually set up the profile contract address and the contract address first, just so you can see what's happening. And then we can do this create profile function after. Where is this profile contract address saved? It's actually saved inside where? Inside, let's take a look at this profile creation here. The connect. Yes, the connect. You notice here we have a contract address and we have a profile contract address. And whenever we connect, yes, let's scroll down a little bit here to the bottom. There it is. We have our connect wallet. And now what we're doing inside here is we're saying, hey, the new contract instance, and then when you have a profile contract instance, whenever we connect, and we connect using our contract API and our contract address, and the profile contract API and the profile contract address, right? So we're connecting to two different contracts all at the same time, so we can talk to them directly. And then we set those using the set profile contracts, and we set them in the use state. Let's set that up right now. I do have it set up for you right here, but again, it's not perfect because I actually want you to set it up yourself with your own contract. So go to your Remix IDE, and the first thing we want to do is we want to publish our user profile contract to the Sepolia network here, correct? So again, let me go ahead and switch up to my MetaMask. Inside our deployment section, go to your environment MetaMask. You can see this one, I have 0.97 Sepolia ETH. And let's make sure you select the Twitter interaction solution or the user one, right? So for me, it's a solution. For you, it might say exercise, whatever it is. And then we just go ahead and we just simply hit deploy. Let's go ahead and do that deploy right there. Hit that confirm. We got it. There we go. So we got our profile. Okay, we got our get profile function, right? Profiles and so forth. Great. Now we need to copy this address. So here, hit that copy. We need to go now to the main Twitter contract right here, the one that incorporates the user profile, and deploy now that one. So go to our deployment section now, inject the provider, blah, blah, blah. And of course, which one are we doing? We're doing the Twitter interaction solution main, this one. Make sure you select it. And I know it says iProfile because it's the interface. You want to select the Twitter one. And it's going to ask you to deploy with the profile contract address. So paste in the profile contract address we copied from the last time, right? And then hit that transact button. There we go. Hit that confirm. And there we go. It was through. And there we go. So now we have both the profile and we have the Twitter contracts all set up. So copy our profile contract address. Again, copy that one right now. And paste it into our profile contract address right there. Save that. Now go back to Remix. Now copy your Twitter contract address and then paste it into the main. There it is. Now that we have those, whenever we connect our wallet, guys, we are going to connect to them using our API and our profile contract API and our profile contract address. And then this set profile and contract and the set contract, what they do is they set that data, they save that data, see the set contract, set profile contract, in the application database. Think of it like that, right? So this set contract changes the value of this. This set profile contract changes the value of this profile contract, right? So now we have access to all of those. And this is why inside here, we can do profile contract.methods.getProfile. Hopefully that makes sense. Okay, so we've got that. And let's go and just test out to see what happens after we connect our wallets here. I'd like to open this in a new window here. Connect wallet, there we go. I wanna use my 3571 right here. Hit next, hit connect. And there we go. It says create your profile because obviously we have no profile. However, if I try to create one, let's just say it says NAS and blah, 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 nothing happens, right? Nothing really happens. Why? Because we haven't added that logic in. For this one, we can do check mark. Great, all good. And then the set correct profile contract address, that is all check mark as well. So we are good on that side. The only thing that's left is complete the create profile function in profile creation.js to create profile for a new user. And that's all you need to do now at this point. So let's go to our components, and the profile creation is actually inside here, this profile creation.js component. You'll notice it right there, okay? Okay, there it is. And so inside here, we have our username input, our bio input, then we have our button. What happens here is that this button, whenever we submit this form, you can see say here, form on submit, it calls the create profile functionality, which is right here, just right here. And this thing is in charge of calling the create profile function in the contract. So let's go ahead and finish this one up. So just like before, I have this little hint for you in terms of how do we actually use Web3.js, right? And there it is. So .send, those you don't know, .call here, this methods .call is used for getting data, right? So if I want to get some data, I do .call. If I want to send data, which costs money on the smart contract side, I do .send. So that's a big difference you need to understand here, and that's really important here. The one we're using is .send because we're changing the state of the contract. We're sending some stuff, right? We're saving some stuff. And that's the whole point of this my method .send right here. We'll send, so my method.send will send transaction to the smart contract and execute its method. Notice can alter the smart contract state, which it does. And all we do is say my contract, that methods, that my method, do .send, and that's all it, pretty much is. And you have some examples right here, very, very simple in terms of what you need to do. So let's go back to our exercise here. So we have enter our code here. So we say here, which one are we going to use? We're going to use the profile contract. There it is. So profile contract dot methods dot what? What is the function that saves the profile in our user profile? Which one is it? It's the set profile function. There it is. And it takes display name and it takes to and a bio. So let's go ahead and go to our exercise here. My methods dot, right, set profile. And we need to pass in two different things. One is the username. And where we get that? Right here in the state. We say username and the bio, which is also coming from the state. So we say here bio, and that's it. And then we do .send. Now, important thing here as well. When we do .send, we say send from what? So from what account here? As you notice here, where from what account? And that's whatever the account you're currently connected with. So we say here send. And it's kind of like this. It's kind of like we use curly brackets. Yes. Boom, right here. Let me go ahead. And then we say from, yes, account. From account. We do want to do an await here. Await, which basically makes sure that it waits for this to finish to then double check, hey, did it finish? Then we check the profile and then we can move on to the next thing, which is allowing you to make a tweet. And that's it. So save that. And well, that's it. Let's just check out if this actually works. So again here, let me go back to right here. Let me refresh this. Connect our wallet 357. So say NAS. Yes, NAS. We say NAS, Smart Contract Developer. Hit the create profile. Oh, would you look at that? Right? Great. Would you look at that? We did that. We hit confirm. Awesome. It's waiting. Again, this waiting is all happening because of why? Because of this await. Await means, hey, wait for everything to finish and then we can move on to the next thing. And again, we do check profile to double check if it actually saved the contract. And there we go. There it is. Since we connected now to NAS, now we can say, yo, what's up? Hit that confirm. You can, yes. There it is. Yo, what's up? That's my icon. So yo, what's up? There's NAS. Okay, I can see. And if I refresh this, if I use a different, let's just say, connect to a different. So let's switch to this testing account, right? This is different, which is 273, and I hit connect wallet. Notice here, because it's connected to a different wallet, it checks, hey, sees that there's no profile and it asks me to create my username. And that is it, my friends. You have made yourself a Twitter DAPP that you can go ahead and showcase to everybody else. And it's basically deployed already for you, as you notice it right here. And you've did this using React.js. Those of you who don't know about React, don't worry about this. It takes some time for you to learn it. But once you do learn it, it's a lot of fun. And you're really going to enjoy this. And there's a big, community on YouTube. And now, of course, I like to teach React too. So there's a lot of videos that I've made on YouTube about React.js as well that you can check out on YouTube as well. That's it pretty much. Hope you enjoyed this Twitter DAPP that we just made. I'll see you guys later. Don't forget to hit that big like button. I really appreciate that. Bye.